In this tutorial, I want to talk to you guys about using dictionaries in Python. Now, a dictionary is a special structure in Python which allows us to store information in what are called key value pairs. So essentially, I can just create a bunch of these different key value pairs, and then when I want to access a specific piece of information inside of the dictionary, I can just refer to it by its key. So the word dictionary is actually pretty appropriate here. If you guys are familiar with a normal dictionary, in a normal dictionary you'd have a word and then you'd have a definition associated to that word. So in this situation, the word would be the key. In other words, the word is what uniquely identifies it inside of the dictionary, and then the value would be the actual definition. So this is going to make more sense once we start working with this, but I just wanted to give you guys a quick introduction. So in this tutorial, I want to create a little program that will allow us to convert a 3-digit month name into the full month name. So I could convert, for example, JAN to January, or I could convert MAR into March. I want to be able to have a program that can do that for us. And that's actually a pretty good use case for a dictionary. So we're actually going to create a dictionary, and I'm going to show you guys how we can do that. So the first thing we need to do in creating a dictionary is just give it a name. So I want to give this a specific name. So I'm just going to call this month conversions. And now I just want to set this equal to an open and closed curly bracket. So whenever we create a dictionary in Python, we're always going to want to create it inside of these open and closed curly brackets. And so inside of the dictionary, now we can start defining what are called key value pairs. So I can define a key and then I can give it a corresponding value. And the way that we can do that is just by typing out the key and then typing out the value. So in our case, we're converting 3-digit month names into the full month names. So I would want to type out, for example, JAN, and then I can type a colon, and I want to type out the value I want to associate with it. So we could say January. I could basically do this for every combination. So I could say FEB, and this would be February. And actually, after each one of these, we're going to need to put a comma. So I could do the same for March. You'd say MAR. So essentially what I can do is I can specify an entry inside of this dictionary for each one of these. So this over here would be the key, and this over here would be the value. And here's one thing is all of these keys have to be unique. So if I was to come down here and change this to JAN, this is actually going to give us a little warning. So you can see down here it says dictionary contains duplicate keys. That's a no-no when we're creating dictionaries. So you always want to make sure that the keys are unique. All right, so I'm going to go ahead and create one of these for each one of the months, and then we'll come back and we'll talk about it. All right, so I've gone ahead and created an entry for all 12 of the months. So now we have a bunch of unique keys, and each one of those keys is associated with a different value. So this is the basics of creating a dictionary. Is we have a bunch of these different key value pairs, and now what we can actually do is we can access them from inside of this dictionary. So if I wanted to access a specific key or a specific value, all I have to do is come over here, and I'm actually just going to print it out onto the screen so we can see it. All I have to do is refer to the dictionary by name, so it's just called month conversions. And there's actually a bunch of different ways that I can access these month names. So I could access different entries inside of this dictionary. The first way is just by making a open and close square bracket, and inside here I can just type in one of the keys. So for example, inside here I could type in NOV, and what this should do is it should give us back the full name for November. So when I print this out, you'll see that we get back down here November. So I could do the same thing for any of these. We could say MAR, and now we should get March back. So I'm able to refer to the key, and it's going to go into the dictionary, and it's going to give me the value that's associated to that key. There's actually another way we could do this too. So I could say month conversions dot get, And inside of here, I could also pass in the name of a key. So I could pass in like DEC, and now we'll be printing out December. And what's cool about using this get function is I can actually specify a default value that I want to use if this key is not found. So there's going to be certain cases when we're dealing with dictionaries where you're going to put in a key that might not necessarily map to a value inside of the dictionary. So you'd put in an invalid key. So let's just try to do that. So I'll just put like LUV. That's not a month abbreviation. So when I try to run this, you'll see we get this none down here. And in a lot of cases, you're gonna want to create some sort of a default value. So if I'm in this situation where I have a key that's not mappable to any values inside of this dictionary, I can actually pass it a default value. So inside this .get function, I can make a comma, and now I can pass in like a default value to get printed out. So I can say like not a valid key. And now, when I put in the invalid key, instead of saying none, it's gonna go ahead and say not a valid key. So this is gonna give us like a default value that we can fall back on. So these dictionaries are really awesome, and the keys over here don't have to be strings. So you could also use numbers. So for example, I could say like 0, 1, 10, like I can put any numbers I want over here as keys as long as they're unique. And then I could access those keys just like I normally would down here with this get function or with those open and closed square brackets. So that's sort of the basics of using dictionaries. They can be really useful to store key value pairs. And honestly, you're gonna be using them a lot in Python to store different types of data. Be the value. And where you're gonna put in a key that we put in, that's this none down here. And in a lot of cases, I'm in this situation, dictionary function, I can make a valid key. And now, when I In this tutorial, I want to talk to you guys about while loops in Python. Now, a while loop is basically a structure in Python which allows us to loop through and execute a block of code multiple times. So I could specify like a few different lines of code, and then I could put that code inside of a while loop, and it would basically loop through that code, executing it repeatedly until a certain condition was false. So while loops can be awesome, and there's a lot of situations in Python where we're going to want to loop through specific lines of code. So in this tutorial, I just want to show you guys the bare basics of how while loops work. And then in future tutorials, we're going to use while loops to create little games and stuff like that. So let's talk about while loops. When I create my while loop, the first thing I want to do actually is create an integer. I'm basically creating a variable that's a number, and you don't have to do this for a while loop, but just for our demonstration, I'm going to. So I'm just going to call this I, and I'm going to set it equal to 1. Now what I want to do is I want to create a while loop. So I'm basically just going to say while, and over here I want to specify a condition. And this is what's called our loop condition, or you can also refer to it as a loop guard. And basically we are going to keep looping through the code inside of the while loop as long as this condition is true. So whatever condition I put in here, as long as it's true, we're going to keep looping through the code inside the while loop. So I'm just going to say while I is less than or equal to 10. And now I'm going to put a colon, and I'm going to make a new line. And so anything that's below this while loop declaration and that's indented like this is going to be considered code that's inside the while loop. And so that code is going to get repeatedly executed while this condition up here is true. So I'm just going to put a very simple line of code here. We're just going to print out the value of I, and then down here I'm going to actually increment I. So I'm going to add 1 to I. So I'm going to say I is equal to I plus 1. So basically I'm taking this I value and I'm adding 1 to it. There's actually a shorthand that we can use in Python to do something like this though. I could just say I plus equals 1, and that's automatically going to add 1 to I. So this is like a little shorthand, and you'll see people in Python using that a lot. So over here we basically have our while loop. So I have the outline for a while loop. So we're defining this variable up here, and we're going to keep looping through the code inside the while loop as long as this condition up here is true. So if this condition is false, for example, if I is equal to 11, then we're not going to loop through this code anymore, and we're just going to move on. So down here, I'm actually just going to print done with loop. So this will kind of illustrate this for us. All right, so let's go ahead and run this program. I'm just going to run it, and you'll see down here we get some output. So we're actually going to get numbers printed out 1 all the way down through 10, and then we're printing out done with loop. So basically what's happening is we're printing out every time we go through this loop. So initially I is equal to 1, right? The first thing that Python's going to do when it gets to this while loop is it's going to check this condition. So before it does anything else, it's going to check this condition, and it's going to say, okay, is 1 less than or equal to 10? And that's true. So as long as this guy is true, we're going to go through and loop through all the code inside of here. So we're going to print out I, which has the value of 1, and then we're going to add 1 to I. So now I is going to go from 1 to 2. Now what we're going to do is we're going to go all the way back up here to this while loop declaration, and we're going to check the condition again. So remember, I checked the condition the first time, and then I looped through all the code. Then I go back up to the top and I check it again. So I'm going to say, okay, is I less than or equal to 10? At this point, I is equal to 2. So I is less than or equal to 10. So now we're going to go through and we'll execute all this code again. So I'm going to print out I, so it's going to be 2. And I'm going to add 1 to I, so now we have 3. Then Python's gonna go all the way back up to the top and it's gonna check the condition again. So on every iteration through the loop, before Python does what's inside of this loop, it's gonna check that condition. And as long as the condition remains true, we're gonna keep executing the code inside the loop. Eventually though, in this program, I is gonna end up being 11, right? So on the last iteration, it's gonna end up being 11. We're gonna come back up here and we're gonna say, is 11 less than or equal to 10? Nope. And so since it's nope, we're gonna come down here and we'll print out this done with loop line. So that's the basics of how these while loops work. We're specifying a loop condition. As long as that condition's true, we'll keep executing the code inside of the loop. And after every execution of the loop, we're gonna come back up and check the condition again. So that's how we end up with this printing out down here. So that's the basics of a while loop. And we can use these while loops to do all sorts of things. Like while loops are very, very powerful. In this tutorial, I'm gonna show you guys how to build a basic guessing game in Python. And in this guessing game, we're actually gonna be using all sorts of cool programming structures that we've learned up to this point in the course. So we're gonna be using things like if statements and while loops and variables and all these cool things in order to build this game. So the basic idea is we will specify like a secret word. So we'll have a secret word that we store inside of our program, and then the user can interact with the program and try to guess the secret word. And so what we want to be able to happen is we want the user to be able to keep guessing what the secret word is and keep typing in different responses until they get the secret word right. So that's the basics of what this game is gonna be. And now let's go ahead and create it. So the first thing we want to do is create a variable to store our secret word. So I could say secret word, and we're just gonna set this equal to a secret word. So why don't we make it giraffe? That's a pretty good secret word. And now what we want to do is we want to create a variable that will store the user's response. So I want a variable that will store like all the guesses that the user makes. So I'm just gonna call this guess. And I'm just gonna set it equal to an empty string right now. So now we have the secret word and we have a variable to store the user's guess. And what we need to do is we need to be able to prompt the user to input the secret word. But here's the catch. What we want to happen is we want them to enter the secret word, and if they don't guess it correctly, we want to prompt them to enter it again. And so we can't just use a single input statement. We actually have to use something called a while loop. And we can use a while loop in order to continually ask the person to guess the word until they guess it correctly. So let's go ahead and create our while loop. So I'm gonna say while, and after I say while, I need to specify a looping condition or a looping guard. Basically, this is something that as long as it's true, we're gonna keep looping through this loop. So basically, I wanna keep looping as long as the user's guess is not equal to the secret word. So as long as they haven't guessed the secret word, I'm gonna keep going through this loop. And inside of this loop, what we're gonna do is we're gonna ask them to input the secret word. So I can take this guess variable and I can set it equal to input, and I'm just gonna say enter guess. And so over here, we're basically telling the user to enter in their guess. I'm storing whatever they enter inside of this guess variable. And then what's gonna happen is we're gonna come back up here, we're gonna check to see if the guess is equal to the secret word. If the guess isn't equal to the secret word, then we're gonna do it again. But if the guess is equal to the secret word, then we're just gonna break out of this loop. And so we can come down here and we can just print out a success message. So I could say, you win, because they got the secret word. So this is a very, very simple program, but this is essentially all of the code that we need to be able to build a game like this. So let's go ahead and play our game. We can run it and see how we did. So I'm gonna click play. And down here you can see it's prompting us to enter a guess. So I'm just gonna type in some random text. We can type in whatever we want. And as long as we're not entering that secret word, it's gonna keep prompting us to enter different information. But if I enter in the secret word, so if I enter in giraffe, Now, all of a sudden, the program's gonna terminate and it's gonna say, hey, you win, because we were able to guess the secret word. So that's like a really cool way for us to be able to do this. And we actually have a fully functional guessing game. But I think this guessing game could actually be improved quite a bit. A lot of times when we're making a guessing game, we want to set a limit. So in other words, I want to set a limit for the number of times that the user can try to guess the word. So let's say that the user has 3 tries, right? They have 3 guesses in order to guess the word. And if they can't guess the word after 3 tries, then they're gonna lose the game. But if they can guess the word inside of 3 tries, then they'll win the game, right? I think that would be a little bit more of a fun game. So why don't we try to program that game? Basically, we're going to set a limit on the number of guesses that the user can have. In order to do this, we're going to have to create a couple more variables down here. In other words, we're gonna have to store a couple more pieces of information. The first piece of information I want to keep track of is how many times the user has guessed, right? So we can just make a variable called guess count, and we'll just set this equal to 0 because initially the user won't have guessed. Down in this while loop, every time we go through the loop, I want to increment that guess count, right? So every time we've gone through this while loop, I want to increment that count because that means the user will have guessed. So down here, I'm going to say guess count plus equals 1. And this is just going to add 1 to the guess count. Actually, whoops. All right, so after each iteration of this loop, we're going to go ahead and add 1 to the guess count. All right, so that's the first variable that we're going to need. We're also going to want to store another variable, and this is going to be called guess limit. And basically, this is going to tell us how many times the user can guess the word. So it's going to be guess limit, and we'll basically just say 3. So let's say that the user has 3 tries to guess the word, 3 strikes, and you're out. So the user, if they can't get it in 3 tries, then we're gonna basically say that they lose the game. And I'm also gonna need one more variable here, which we're gonna call out of guesses. And I'm just gonna set this equal to false initially. So this out of guesses variable is gonna be a Boolean, and it's gonna tell us whether or not the user is out of guesses. So if out of guesses is true, that means they have no more guesses, right? They basically lost the game. And if out of guesses is false, that means that they still have some guesses left so they can keep playing. All right, so let's use these different variables in order to make our program more functional. So the first thing I wanna do is when I go through this loop, I wanna check to make sure that the user has more guesses, right? In other words, before I let the user enter a guess, I wanna check to see that they haven't already used up all their guesses. So down here, I can make an if statement. I can say if, and inside of the condition, I wanna check to see that guess count is less than guess limit. If guess count is less than guess limit, that means that they haven't guessed the total number of guesses that they have, so they have some guesses left. And if that's the case, and if that's true, then I'm gonna go ahead and give them a guess, and then we'll increment the guess count. If this isn't true, in other words, if they have reached their guess limit, then I'm gonna wanna set out of guesses equal to true. Because they're out of guesses, right? They have no more guesses because the guess count wasn't less than the guess limit. And so that means that they're out of guesses, so they have no more guesses. So there's actually one more thing we need to do inside of this while loop. We need to add another condition onto this loop guard. So right now, we're gonna keep looping as long as the guess is not equal to the secret word. But remember, if the user's out of guesses, in other words, if they've reached their guess limit, we don't want them to guess anymore, right? So if they ran out of guesses, then we want to basically break out of this loop and not give them any more guesses. So I'm gonna go ahead and add another condition onto here. And I'm gonna say, while they haven't guessed the secret word and they're not out of guesses, so it's gonna be not out of guesses, then we're gonna keep looping. So as long as they haven't guessed the word and as long as they still have some guesses left, we're gonna keep looping. But otherwise, we're gonna break out of the loop. And so down here, we're printing out you win. But actually, when we break out of this loop, there's gonna be two possible scenarios. So again, there's two possible ways that this loop could end, right? Either the guess is equal to the secret word, so either the user guessed the word correctly, or the user ran out of guesses. And so there's two situations down here that we need to account for. And so I'm gonna use an if statement to figure out which is which. So I'm gonna say if, and we're just gonna type out of guesses. And if the user is out of guesses, then I wanna print out of you lose. So we're basically gonna be like, you lost the game. Otherwise though, if they're not out of guesses, that means that they guessed the word correctly. So we're just gonna print out you win. All right, so now we have all of the logic for this little guessing game set up, and let's see if we can run it and play through it. So I'm just gonna run this program, and now it's gonna tell us to enter a guess. So why don't we enter more guesses than we have? So we're gonna try to lose the game. So I'm just gonna enter one guess, two guesses, and now I'm on my final guess. So if I don't get it here, we should actually lose the game. And you can see it says, out of guesses, you lose. So we weren't able to guess it in the number of tries that we had. Let's run the program again and we'll try to win the game. So we'll get a couple wrong. Let's say we're on our last guess and I'm like, okay, I can do this. So I type in the word and bam, we won the game. So that's how we can basically create a game where we have a guess limit. So this is a lot of code. Let me walk you guys through this one more time so you can just get a full understanding of what we're doing. Up here, I created a few different variables. We created this secret word variable, and we created this guess variable. And then we also created some more variables. So we created this guess count variable. And this just keeps track of how many times the user has guessed the word. And you can see down here, every time we give them a guess, we're incrementing the guess count. We also have guess limit. And guess limit is telling the program how many times the user can guess. So before I go through this while loop, the first thing I'm doing is I'm checking to see that the guess count is less than the guess limit. In other words, do they still have some guesses left? If they do, then we're gonna get the input from the user. Otherwise, we have this other variable up here called out of guesses. And out of guesses is gonna tell us whether or not they have some guesses left. So if this is equal to false, that means they have some guesses. If it's equal to true, however, it means no more dice, no more guesses, they are done. So they lost the game. The last thing we needed to do was specify an additional condition up here. So we are gonna keep looping through the code inside of this loop as long as the conditions up here are true. So as long as they haven't guessed the word, and as long as they're not out of guesses, we are going to keep looping through. And so when eventually the user does break out of this loop, there's gonna be two possible situations. The first situation is that they ran out of guesses. And so we wanna check to see if that's the situation. I wanna check to see if they're out of guesses. If they are, we'll print out a lose message. If they're not, then they must have guessed it correctly, so they win. And so that is how we can use while loops and if statements and also variables in combination with each other to build a pretty awesome guessing game. In this tutorial, I want to talk to you guys about using for loops in Python. Now, a for loop is a special type of loop in Python which allows us to loop over different collections of items. So a lot of times we'll use for loops in Python to like loop through different arrays, or we could loop over like the letters inside of a string, or we could just loop through like a series of numbers. So for loops provide a very specific purpose, and the easiest way to kind of wrap your head around why for loops are useful is just for me to show you guys a bunch of different examples. So that's exactly what I'm gonna do. We're gonna look at why for loops are awesome. So down here in my text file and my Python file, I'm gonna write out a couple different for loops. So the way that we create a for loop is just by saying for, and now what I wanna do is specify a variable. And this variable is going to essentially represent a different value every time we go through this for loop. And you guys will see how that works in a second. But just know that this variable is going to be used on every iteration of our for loop. And each time it will most likely have a different value. So in our case, I'm just gonna call this letter, and I'm gonna say for letter in, and now what I wanna do is I wanna specify a collection that I wanna loop over. One example of this would be like a string. So I could put a string in here. I could just put like Draft Academy, and now I can just put a colon. And so basically what this is gonna say is it's gonna say for every letter inside of Draft Academy, I wanna do something. And so down here inside of this for loop, and again, we need to indent this, we can put what we wanna do with each letter. So let me just show you guys like basically what this is gonna do. So I can print out letter, so I can print out this letter variable, and it's actually gonna print out a different letter inside of this Draft Academy string on every single iteration of this loop. So I'm gonna run this program, and down here inside of my console, you'll see that I'm basically printing out Draft Academy. So on the first iteration of the loop, I printed out the first letter in Draft Academy, which was G. On the second iteration of the loop, I printed out I, third was R, fourth was A. So I'm essentially just looping through all of the letters inside of Draft Academy. So I'm saying for each letter in Draft Academy, I want to print out that letter. And so this is kind of like how for loops can be used. We can define a variable, and that variable will change on each iteration of the loop, right? So on the first iteration of the loop, this letter variable represented a G. On the second iteration of the loop, the letter variable stored the value I, etc., right? So we went through this entire string and we were able to print out each letter. So in addition to using this with strings, we can also use this with other collections, for example, like an array. So if I created an array up here, let's just call it friends, I'm gonna set this equal to a bunch of different values. So we can put like a list of our friends in here. We can say like Jim, Karen, and Kevin. Instead of saying letter, why don't we call this friend? And I could say for friend in friends. And now we'll print out the friend. So over here, I'm saying for each friend inside of this friends array, I want to print out the friend. So now we'll actually be able to print out each element inside of that array. So down here you'll see we're printing out Jim, and then on the second iteration we're printing out Karen, and on the third we're printing out Kevin. So I'm able to loop through all of the values inside of the array. And just so you guys know, like, you can name this variable whatever you want. So I could give this like any random name, and if I want to access it though, I have to access it using that same name. So we can loop through something like an array. We could also just loop through a series of numbers. So I could say index over here, and again, this can be anything. I'm just gonna call it index. So we could say for index in range, and then in here I can pass in a number. So I could pass in like 10, for example. And down here I'm just gonna print out the index. When I run this program, you guys will see that it's basically gonna print out every number in the range from 0 to 10, not including 10. So starting with 0, it's gonna print out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But notice that it didn't print out 10. So it's essentially just printing out all the numbers between 0 and 10, not including 10. You can also specify a range of numbers. So I could say, for example, like 3 and 10. And now this will print out all the numbers between 3 and 10, not including 10. So we'll run this program, and you can see we print out 3, 4, 5, 6, 7, 8, 9, and not 10. So whatever value that you put here in this second position is not going to get included in the range. And ranges can be really useful. So for example, I could use a range to loop through an array just like we did before. So if I wanted, I could say something like for index in range, and now inside of this range, I can pass in the length of the array. So just so you guys know, if I wanted to get the length of this array, in other words, if I wanted to figure out how many elements were inside of it, I could just type out len and then inside parentheses the name of the array. And so this is gonna spit out 3 because there's 3 elements inside of here, right? Kind of makes sense. So what I can do is I can say down here inside of this range function, I can just type in len and then friends. And so what this is gonna do is it's gonna essentially give me a range between 0 and the number of friends inside of this list. So down here I could actually type out friends index, and this will allow me to access each individual friend inside of this list, just like we did before, but now I'm doing it with a range. So you can see I'm typing out Jim, Karen, and Kevin. So actually, for each iteration through this loop, it's basically gonna be printing out friends 0, friends 1, and then friends 2, because in here we're passing in a 3. And remember, whatever I pass in there, it's gonna range from 0 all the way up to that number, but not including that number. So that's another way that we could print out all the elements in the array. And looping through something like an array is actually a very, very common use case for loops. But like I said, we can use for loops to loop through essentially any collection that we have. So we could loop through like a string. We could also loop through, something like an array. So this can be really useful, and that's sort of the basics of for loops in Python. And I also want to show you guys one more example just while we're here. So why don't we go ahead and print out a range up to 5, right? So this will just be a simple program. You can use all sorts of logic inside of these for loops. So let's say that I wanted to do something special on the first iteration of the loop. So I could say if index is equal to 0, and if the index is 0, then we know it's the first iteration of the loop. So I could do something special. I could like print out first iteration, and then otherwise we could just print like not first. So this would be an example of like, maybe you want to do something on the first iteration of the loop and do something else on subsequent iterations. So if I play this, you'll see only on the first iteration is it printing this out, and otherwise it's printing out other stuff. So, don't be afraid to put some complex logic inside of these for loops, because it can really make your programs more powerful. In this tutorial, I'm going to show you guys how to build an exponent function. Now, an exponent function is basically going to allow us to take a certain number and raise it to a specific power. So in Python, there's actually a really easy way to do this. I could come down here and I could print, we could say like 2, and we can just do 2 multiplication signs, and I could say 3, and this is basically just going to be 2 raised to the 3rd power. So you can see here, I can just print this out and we get 8 because that's 2 cubed. So it's really easy to do exponents in Python, but I want to show you guys how we can use something like a for loop in order to create a function like this of our own. So we'll actually create an exponent function that will basically do this, and we'll use for loops to do it. So let's create a function. So I'm just gonna say def, and now we need to give this function a name. So why don't we call it raise to power? And inside of here, I'm gonna accept 2 parameters. The first parameter is gonna be the base number, and then the second parameter is gonna be the power number. So we're gonna take the base number and raise it to the power number. So over here, we can just make a colon. Now, inside of this function, we need to start writing some code. Here's the thing. Inside the function, we don't necessarily know the value of this pownum, right? For example, if we knew that we were just trying to like square this number or cube this number, I could just return like base num times base num, right? That would square the number, or I could cube the number base num. So this would be like the number cubed. The problem is though, we don't know like right off the bat what this value is gonna be, right? This could change, like the user can decide that. So in order to write this function, we're actually gonna need to use a for loop. And I'm gonna show you guys how we can use a for loop to basically figure this out. So the first thing I wanna do is create a variable, and I'm just gonna call it result. And we're just gonna set result equal to 1. So we're gonna start this off at 1. Now I want to create a for loop. So I'm basically just going to say for, and over here, I basically want to specify like a index. So I'm going to say index and now I want to specify a range. And a range will basically range us through a collection of numbers. So basically I want to multiply the base num by itself as many times as the pow num specifies, right? And so over here, I can just make this a range of pow num, right? And so we'll basically loop through this for loop as many times as pow num. So if pow num is 2, we'll loop through it twice. If pow num is 4, we'll loop through it 4 times. And every time through the loop, we'll multiply base num by itself. Or actually, you'll see we're gonna multiply it by this result. And so down here inside of this for loop, I can basically say result is equal to result times base num. This should actually give us everything we need to take this number to the specific power. So the actual like result, of doing the math is gonna get stored inside of this result variable. So the first time through the loop, we're just multiplying base num by 1, right? And so now result is gonna become the same value as base num. The second time through the loop, so this would be if we were squaring the number, we're basically multiplying result by base num again. So it's essentially just base num times base num. The third time through the loop, we're multiplying result times base num. So we're essentially just like cubing the number. So that's essentially what this for loop is doing for us. So the last thing I wanna do is right here below this for loop, I'm just gonna return the result. So we'll be able to return whatever the result of raising the number to the power was. All right, so let's come down after this function and we're just gonna call it. So I'm just gonna say, actually we'll print out the answer. So I'm gonna say raise to power, and inside of these parentheses, remember we can pass 2 numbers. So let's raise 3 to the second power. So we're just gonna square 3 and we'll see how this works. So let's run the program. And you can see down here in the console, we're getting 9. Let's try something a little bit crazier. Let's try 3 to the 4th power. And we'll run this and we get 81. So that's 3 to the 4th power. Let's try 2 to the 3rd power. And we're getting 8. Yeah, so that makes sense. So our raise the power function is working just as expected. And I'll just walk you guys through it one more time. So inside of this function, we're taking in 2 pieces of input. We're taking in a base number and we're taking in a pow number. So that's like the base number is gonna be taken to the power number. I'm defining a variable here called result. And result is where we're gonna store the actual result of doing the math. Now we specify this for loop. And I'm basically saying that I wanna loop through this range of numbers. When I put pow num here, it's basically gonna range from 0 all the way up to, but not including the power number. So we'll basically loop through power number of times, if that makes sense. And then every time through the loop, we're just multiplying result by base num. And then we're just returning result. So that's the basics of building a power function. And obviously, like if you're just trying to take a number to a power in Python, it's really easy, but this kind of shows you like the internal workings, right? For a function like that to work, we would have to actually type something out just like this. In this tutorial, I want to talk to you guys about 2 different concepts in Python. It's going to be a pretty cool lesson. First thing I want to show you guys though are 2-dimensional lists. So down here in our Python file, I just want to create a basic list. So I'm just going to call this number grid, and I'm just going to set this equal to a normal list, right? Just like this. Now normally if we were creating a list, I could just put in a bunch of attributes, a bunch of elements, right? And now all of these elements are inside of this number grid list, everybody's happy. But another thing I can do is I can make all of the elements inside of this number grid list lists. So the first item in the number grid list is gonna be a list, the second item in the number grid list is gonna be a list, etc. So I'm gonna show you guys how to do that. I can basically just come down here, and where I would normally put the first element in the list, I can just create another array. So I'm just gonna make an open and closed square bracket. And now I'm just gonna say 1, 2, 3. And I can create the next item in my list. I can say 4, 5, 6. And let's make another item in this list. I can say 7, 8, 9. And finally, we're gonna put one more list inside of the number grid list, and it's just gonna have 0 in it. So inside of this number grid list, right, this high level overall list, we have 4 elements. And all of those elements are themselves lists. So essentially what we're doing is we're creating a grid, right? This grid has 1, 2, 3, 4 rows and 1, 2, 3 columns, right? 4 rows, 3 columns. And that's kind of like why these can be useful, is we can create a grid-like structure inside of Python using 2-dimensional lists. So this is a pretty cool list structure, and I want to show you guys how I can access individual elements inside of this list structure. So for example, let's say I wanted to print out one of these values. Let's say I wanted to print out this 1 right here. The way I can access it is by saying number grid, and the first thing I want to do is make an open and close square brackets, and in here I want to put the index of the row that I want to access. So this would be like row 0, because that's the 0th element in the array. This would be row 1, it's at index position 1. This would be row 2, row 3, etc. So I could put row 0, and now right next to this I'm going to make another square bracket, and I want to put the index of the column. So this would be like column 1, column 2, column 3. So I'm going to put another 0 because this is at the 0th index of this first array. So I just put 0, 0 here. Now we can print this guy out to the screen, and you'll see down here that we get that 1. So I could also do this for this 8, for example. So this is going to be 0, 1, 2. It's going to be row 2 and column 1. And now we should be able to print out that 8. So that's basically how we can access elements inside of this 2D list. The next thing I want to show you guys is a nested for loop. A nested for loop is a situation, like I said, where we have a for loop inside of a for loop. And I'll show you how we can use this nested for loop in order to print out all the elements inside of this array. So I'll basically show you guys how to parse through a 2-dimensional list or a 2-dimensional array. All right, so basically we're just gonna create a normal for loop. So I'm gonna say for, and I'm just gonna say row in number grid. And I'm using the word row here because I'm kind of seeing these guys as rows, right? These are sort of horizontal rows in our little grid. So for each of those rows, for each of the elements inside of number grid, I want to loop through. So I could actually just print out each row right now, and it's just gonna print out all the rows inside of this list. So you can see down here, we basically just get exactly what we have up there. But I want to be able to access each of these individual attributes inside of each of these array elements. So we can actually create another for loop, and I'm going to put that for loop inside of here. So now I'm going to say for column in row. And basically what this is going to give us is each individual column or each individual element inside of these arrays. So for example, inside of the arrays that are the elements of the number grid. Hopefully that makes sense. So down here, now I can just print out column, and this should actually print out every single value inside of this 2-dimensional array. So let's go ahead and run this program. And down here, you'll see that we're basically printing out 1 all the way down to 0. So we're printing out all of the elements inside of all of the arrays inside of the number grid. So that's how we can use 2-dimensional lists and nested for loops together. And both of those things are actually pretty handy in Python. Handy lists and nested for loops together. And both of those things are actually pretty handy in Python. In this tutorial, I'm going to show you how to build a basic translator in Python. So essentially we can take in a string, so we can take in like a phrase or a word, and we'll be able to translate it into a different language. So over here I have this little file, and it basically specifies this language that I made up. So I'm calling it the draft language. And in the draft language, all vowels become G. So if I was going to translate an English word into a draft word, for example, the word dog, I would look through the word dog in any instances where there was a vowel. So in our case, let's just say A, E, I, O, or U. I would convert that vowel into a G. So dog would map to DGG, cat would get mapped into CGT. So those are the basic translation rules. Obviously this is a pretty simple language, but you get the point. Any vowel is going to become a G, and then we'll get the draft language. So we're going to build a draft translator. Over here in our Python file, let's start making this translator. The first thing I'm going to do is just define a translate function. So I'm going to make a function here, and I'm just going to call it translate. And inside of these parentheses, we want this to take one piece of information, which is going to be the phrase that we want to translate. So I'm just going to say phrase. And now inside of this function, we need to figure out like, okay, how can we translate English into our draft language? Well, remember, the rules is basically just any vowels become G's. So the first thing I want to do is create a variable, and this variable is going to be the translation. So this will be like the final result that we're going to return to the user. So I can say translation. For now, I'm just going to going to set it equal to the empty string. So this is just going to be like a completely empty string. It's not going to be doing anything. And now what we want to do is we basically want to loop through every letter inside of this phrase, and if it's a vowel, we want to change it to G, and if it's not a vowel, we want to leave it alone. And we're essentially going to be looping through phrase, and we're going to be adding the letters onto this translation one by one. So let me show you guys how we can do this. I'm going to make a for loop, so I'm going to say for, and I'm just going to say letter in phrase. And so now when I loop through here, I can access each individual letter inside of the phrase that they passed in. So what I want to do is I want to check to see if the letter is a vowel or not, right? If it's a vowel, then we can add a G onto translation. If it's not a vowel, then we can just add on whatever letter it was onto translation anyway. So I'm going to use this if statement. I'm going to say if And there's actually this special thing we can do in Python. We can check to see if something is in something else. So I can say if letter in, and over here I'm just gonna type out all the vowels. So we'll say A, E, I, O, U, and A, E, I, O, U. So I'm basically checking to see if the letter is inside of this string. And if the letter is inside of here, then we know that it's a vowel. So down here, we can handle that case. So I can say translation is equal to translation plus G. Because if this letter is a vowel, we just want to convert it into a G. Otherwise, though, I can basically just say translation is equal to translation plus letter. So in the case where we have a vowel, I'm adding a G onto translation. In the case where we don't have a vowel, I'm just adding on whatever letter it was onto translation. So finally, down below this for loop, we just want to return the translation. So I'm just gonna say return translation. And now we have a awesome translate function, and it should probably work. So let's come down here and we'll test it out. So why don't we allow a user to input some information? So I'm basically gonna call this function, actually we're gonna print it out. So we'll print this out and I'm gonna call this function translate. And inside of here, I'm actually just gonna pass whatever the user inputs. So I can just say input, and inside of these parentheses, I can say the prompt. So enter a phrase. And so now I'm basically combining all of these statements together. I'm saying I want to print out the translation of whatever the user enters in. So let's go ahead and run this program and we'll see how we do. So I'm gonna run the program. It says enter a phrase. Actually, let me format this a little bit better. Okay. All right, so it says enter a phrase. So let's go ahead and do that. So let's just type in the example we used before. I'm gonna say dog. And so now out pops the answer, which is DGG. So that's kind of cool. And we can just keep running this as many times as we want. So I could type in like to be or not to be. So this is like a little bit longer of a string. And you can see it translates it into our draft language. So that's basically how we can create our little translator app, and that's pretty cool. And so you can see we're using a for loop in combination with an if loop, and that's a really powerful structure. And actually there's one place over here where we can make this a little bit more efficient. So instead of saying if letter in this string, you'll notice here I'm checking to see if it's in all the lowercase and the uppercase. I could actually just say if letter dot lower in, and now I only have to type out the lowercase letters and it's still gonna do the same exact thing. So that's a little like hack or whatever that we could use. And there's also one more problem with this program. So you'll notice down here, we're setting the translation equal to the translation plus G. But the problem is if I was to start my word inside of the phrase with a capital vowel, so in other words, if I said like on, you'll notice that when this gets printed out, it gets printed out as lowercase gn. So it's not keeping our uppercase syntax. And that's kind of a problem. So we could actually use another if statement in here, and we could check to see if letter dot is upper. And if the letter is uppercase, then we can just set the translation equal to the translation plus a capital G. Otherwise, we can just set it equal to the lowercase g. And so now we're able to control both of those situations. So let's just test this and see if it works. Enter a phrase, say on, and now we're keeping that capital letter. So those are just a couple different ways that we could make this program a little bit better. But the basic concept is we have a for loop and then we have some if loops inside of it, and we're calling this awesome function that can translate a word for us.
I am within transition.
You're within transition.
Yes.
In this tutorial, I want to talk to you guys about comments in Python. This is going to be a pretty short tutorial. I just want to give you guys an overview of what comments are and how we can use them in our Python programs. So over here in my Python program, I just have this line here. It says print comments are fun. So if I run my program down here inside of the console, it's going to print out comments are fun, right? So any code that I put over here is going to get executed by Python. But there's actually a special line of code that we can write, and it's called a comment. And a comment is basically a line inside of our Python file that's just not going to get rendered by Python. So when Python sees it, it's just going to ignore it. It's not going to execute it. It's not going to print anything out. It's just going to kind of ignore it. And comments are basically just used for us humans. So a comment is used for like me or another developer to write a little comment, a little like plain text, comment inside of a file. So in order to create a comment, I could use this hashtag symbol. So I can click hashtag, and now I'm writing a comment. So I can write whatever I wanted in here. I could say like, this program is cool. And you'll notice when I run the program, that doesn't show up anywhere, right? It doesn't matter what I put after this hashtag. This is just like ignored by Python. It's just for me or another developer to come in here and use. So a lot of times if you want to write like a little note inside of your Python files, or maybe you can write yourself a little reminder, or if you want to write a line to like explain a line of code. So for example, I could write a comment that would explain this print statement. So I could say like, this prints out a string, right? Now anybody looking at my file would be able to read this and they'd be like, oh, that's what this does. Okay, cool. So comments are useful for leaving little comments in a Python file. If you want to make comments on multiple lines, you can just create a new line and use another hashtag. And so then I could type out whatever my next comment was. And generally, if you're going to put comments on multiple lines, you want to just use multiple hashtags. But there's actually another way that you can write out comments. So you can use a triple quotation mark. So I'm typing out the single quote, and I'm typing it out 3 times. So you can see here, up here we have this 3 times, we have this 3 times. So in here I can, write any comment that I wanted. So I could put, as much text up here as I would want. And same thing, when I run this program, it's just not going to get rendered. So this is another way to make multiple line comments. But the official Python style guides or whatever just recommends that if you're going to put comments on multiple lines, you use these hashtags. So you can really do whatever you want, but if you want to be super Python official, then use these hashtags. Comments can also be useful for doing something called commenting out a line of code. A lot of times when you're writing a program, you might have a line of code in there that is maybe potentially messing stuff up. And so what you can do is you can actually comment out that line of code. So I could put a comment in front of this line of code, and now when I run my program, the program's gonna run, but it's not gonna use this line. So sometimes if you're trying to see if a line of code is causing you trouble, or if you wanna see what your program would be like without a line of code, or even a block of code, you can just comment it out. And that way you're not actually deleting the code from your file, you're just commenting it out, so Python's gonna ignore it. And those are really the 2 uses for comments, is to write little notes, write little comments about different things, or to comment out code. And as you go forward in Python, I'm sure you'll find uses for comments. In this tutorial, I want to talk to you guys about catching errors in Python. Now, a lot of times when we're writing Python programs, you'll encounter different errors. So different situations could come up and your program might throw an error, or it might throw an exception. And a lot of times when these situations happen, they'll completely stop your program from running. And what we can actually do is we can watch out for certain specific errors that are gonna pop up in our program, and we can actually handle them. So instead of our program just breaking and stop executing, we can actually handle those errors and do things when they occur. So I want to show you guys an example of using this. Down here I'm saying number is equal to int input enter a number. Basically what's happening is I'm prompting the user to enter in a number using this input command, and then I'm converting whatever they entered into an integer. So as long as they enter in a valid integer, I can convert it into an integer. So I can convert it into a whole number, and I can store it inside of this number variable. Then I'm just printing it out. So let's try to execute this program. I'm gonna run the program, and you'll see down here it says enter a number. So we can enter in like 4, for example. And when I enter in 4, everything's gonna work, and it's just gonna print out 4, and everything is right in the world. And actually I'm gonna modify this up here so it's a little easier to see. But let's say we run the program again. So it says, okay, enter your number. Let's say that I break the rules and I don't enter a number. So I just ignore what the prompt says and I put, some random text in here. Now when I enter this, the program's gonna throw an error. You can see down here it says value error, invalid literal for int base with base 10. Basically, hey, you didn't enter in an integer like you said you would, right? We told them to enter in a number, they entered in text, so it broke the program. And this is a situation that happens a lot. So there's a lot of different situations where something can just go wrong in our program. And up until now, we've just kind of accepted it as a reality. But if you're writing a real live Python program, you don't want something like this to trip up your program. You don't want the entire program to break when somebody just forgets to enter in a number, right? You want to be able to handle all these different situations. And in order to handle them, we can use something called a try except block. And a try except block will basically allow your program to try out a piece of code, and if everything goes well, then we're great. Like, we could try out entering in the number, and if the user enters in the correct number, great. But if they don't enter in the correct number, then we can basically like account for that. So if they entered in something like a string when they're supposed to enter in a number, we could tell them like, hey, you entered in the wrong thing. So I'm gonna show you guys how we can use these try except blocks. I'm gonna come up here, and I'm just gonna say try. I'm gonna make a colon, and now I want to indent both of these things. So both of these things are gonna be inside of this try block. Now I'm gonna make a new line. I'm gonna come down here and I'm just gonna type out except. And I'm also gonna put a colon here. And down here, I'm just gonna print something out. So I'll just say like invalid input. So now, since I put this code inside of this try block, if the user enters in something wrong, it's gonna be able to catch it. So it'll be able to catch what the user does wrong and print out invalid input onto the screen. So let's go ahead and run our program. And it's just gonna say enter a number. So we're gonna ignore that. We'll enter this in. And now instead of yelling at us and breaking the program, it just says, hey, invalid input. So it was able to handle the error that got called. It was able to handle the invalid input error. Basically just told us, hey, no more input. So this is a really powerful thing that we can do in our Python programs, basically just to protect our programs, right? If I want to have my program running for long periods of time, I can't have something as simple as an invalid input trip it up. So I can catch that invalid input using these try except blocks. But here's the thing, you'll notice that this little guy down here is getting highlighted. And let's just see what it has to say. So it's basically saying too broad exception clause. And this is a message that we're getting because when I just say except, this will catch any error under the sun. So anything that can go wrong in my program, for the most part, this is gonna accept it. So let me give you guys an example. Let's say I had in my program, I was creating a variable, right? So I wanted to create a variable called value, and I set it equal to 10 divided by 0. Now, if you know anything about math, you'll know that you can't divide a number by 0. It's not possible. So the program isn't gonna be able to handle this, and you'll see that this is gonna throw an error for us. So when I run the program, it basically says 0 division error, division by 0. We're not allowed to do that, right? If I took this and I put this down inside of this try block, and I just pasted it in here, it's gonna get caught by this exception that we wrote down here. So it's gonna get caught by that except. So when I run the program, you'll see it says invalid input. But the problem is that we didn't input something that was invalid, right? We just divided by 0, but it wasn't able to handle that, right? So it could not divide by 0, it threw an error. So even though we didn't get an invalid input, even though it was because we divided by 0, it still printed this out. And this brings me up to another point, is we can actually catch, or we can accept specific types of errors. So for example, in this case, we got a division by 0 error. In this case, we got an invalid input error, right? We put something in that was wrong. It couldn't convert the value. So I can create 2 different except blocks to catch 2 different types of errors. So down here, I can just make a space and I can specify the type of error that I want to catch. So when we divided by 0, it was zero division error. So if I just put zero division error in here, now it's going to catch that zero division error. So I can say divided by 0. I could also make another except, so I could say except, and we can catch the other exception that we got. So I think it was a value error, right? It was, we put in the wrong type of value inside of that input. So now we can print out invalid input. So with these two except blocks, we're basically able to handle both of these situations. So for example, if this ends up breaking the program, this division by 0, then it'll be able to catch that. So down here, it'll tell us, hey, you divided by 0. But if I was to get rid of this line of code and I just entered in the number wrong, so I came down here and I entered in a string instead of a number, now it's gonna tell us invalid input. So we're gonna be able to specify what happens when certain things break. So when we get a value error, we can say invalid input. When we get a zero division error, we can say divided by 0. So depending on what breaks, depending on what happens, we can actually do different things. And I want to show you guys one more thing we can do, which is we can actually store this error as a variable. So I can say except, and I can say as, and I can type in a name here. So a lot of times people will just say like ERR. And down here, I can print out the actual error. So I could just print ERR. And so if we end up dividing by 0, so if I say answer is equal to 10 divided by 0, we're gonna throw this error and it's gonna print out what went wrong. So now I can run this program and it just says division by 0. So it just printed out the error that we got. So that's another useful thing you can do, is you can actually like print out the specific error that got thrown. Now, a best practice in Python is to use these specific errors. So you always want to accept for a specific error. What you don't want to do is just say accept and then just accept anything under the sun. It's just too broad and it's not a good practice in Python. So you always want to be catching specific errors like this. In this tutorial, I want to talk talk to you guys about reading from external files in Python. Now, a lot of times in Python, you're going to want to read from files that are outside of your Python file. So you might want to read information from like a text file or a CSV file or like an HTML file. And you can actually use something called the Python read command, and it will allow you to read a file that is stored outside of your Python file. So you can use these files to get information, or you can parse through different files and do different things. So I'm going to show you guys the basics of reading files, opening files, closing files, doing all of that stuff. Over here, I have this file called employees.txt. And it basically just lists out a bunch of different employees. Like these could be employees in an office or whatever. So it's just listing out all of this information. So let's say that inside of my app.python file, I wanted to read the employees inside of that file. The first thing I have to do is actually open that file from inside of Python. So I can use a special command called open. So I can say open, and then in here, I can type in the name of the file that I want to open. So this is either going to be a relative path to the file, an absolute path to the file, or just the file's name if both files are in the same directory. So in my case, app.python and employees.txt are in the same folder, like they're in the same directory. So I can just type out the name of the file. I can just say employees.txt. And now I want to put one more thing inside of this open function, and it's going to be the mode that I want to open the file in. So you can actually open files in a couple different modes, and the first mode is called read. So I can just put an R here, and that's going to stand for read. And this basically means that I only want to read the information inside the file. I don't want to modify it, I don't want to change it, I just want to read it. I just want to see what's in the file and do some stuff with that information. Another mode is called write, so I can type in this W. And writing basically means that you can change the file, right? You can write new information, you can change existing information. There's another one called A, and A stands for append. And this basically means that you can append information onto the end of the file. So you can't modify any of the information in the file, you can't change any of the information, but you can add new information. And there's one more, which is R+. And this basically means read and write. So this will give you all the power of reading and writing. So in our case, we're just gonna be working with regular R. So we're gonna be reading from the file. Now this open function will essentially just open the file. So it's gonna like go over to that file inside of our file system, open it up, and it'll allow us to read through it. But generally, we're gonna wanna store this opened file inside of a variable. So I can create a variable and we can just call it employee file. And I'm just gonna set it equal to this open function. So now the open employees.txt file and all the content inside of it is stored open, working with function of reading, and this content inside of it is stored inside of this employee file variable. Now, whenever you open a file, you always want to make sure that you close the file as well. So just like we have this open command, we also have an close function. So I can come down here and say employee file dot close. And this is essentially just going to close the file. file, so we're no longer going to be able to access it. And generally, it's a good idea whenever you're opening up a file, you want to also make sure that you're closing the file at some point. So generally, once you're done reading it, you can just close it. So that's kind of like how we can open and close a file. Now, let's talk about how we can get information from the file, right? There's no point in having the file there if we can't figure out what's in it. So there's actually a few different functions that we can use on this employee file to figure out what's inside of it. And I'm going to show you guys some of those. So I'm just going to make a print statement, and inside this print statement, we'll basically just print out some information about the employee file. So the most basic thing we can print out is just the entire contents of the file. But before I do that, I want to show you guys how you can check to make sure that a file is readable. So before we do anything else, generally it's a good idea to make sure that it's possible to read this file. And there's a function inside of Python we can use called readable. So I'm just going to type out employee file dot readable. And this is going to return a Boolean value, and it's going to tell us whether or not we can read from this file. So I'm going to run my program, and you'll see down here we get a value of true. And that's because we set the file with a read mode. So it's in read mode, we can read from it. If I was to put a W here, so if I put like write, now readable is going to be false because we can no longer read the file, we can only write to the file. So I'm going to change this back to R so we can just read it. So once you figure out whether or not the file can be read from, let's actually read it. So there's another function called employee file.read, and this is basically just going to spit out all the information in the file. So when I run the program, it's just going to spit out all of this information, right? All the information that was in that file. I can also come down here and we could read an individual line inside this file. So I can say employee file.read line. And what this is going to do is it's going to read an individual line inside of this file. So now when I run this program, you'll see it's just reading that first line in the file. And this read line function is actually just reading the first line, and then it's basically like moving a little cursor onto the next line. So if I was to copy this line of code and then print it again down here, I'm saying employee file.read line. So it's gonna read the first line, and then when I say it again, it's gonna read the line after that. So this is actually gonna end up printing out the first two lines in the file. So when I run this program, you'll see we print out Jim Salesman and Dwight Salesman. So if I was to do this multiple times, like I could technically print out every line inside of this file. And you can see we can do that. And so that can be pretty useful for reading multiple lines in a file, but there's actually another function that is better at doing that. And we can say, instead of employee file.read line, we can say .read lines. And what this is going to do is it's going to take all of the lines inside of our file and put them inside of an array. And so now when I print this out, you'll see we have this array down here. It says Jim Salesman, that's the first item in the array. Dwight Salesman, the second item in the array. It's basically taking each line and putting it inside of an array. So if I wanted to access a specific line, I can just refer to it by its index in the array. So if I said 1, now this is going to give us that Dwight Salesman line, because that is at index position 1 inside of the array. You can also use this read lines function with a for loop. So I could come up here and create a for loop. I'm just going to say for, and we'll say employee in employee file. And then for each employee, we just want to print them out. So, and actually, sorry, we have to put employee file.read lines up here. And so now this will loop through all of the employees in this employee file.read lines array. So we can actually just print out the individual employee. And now this will print out all the employees inside of that file. So it's basically printing out each line in the file. And that can be pretty useful. So you can use all of these different functions like read, read line, read lines, readable. You know, there's a bunch of these different things that we can do to get information from a file. And so there's a lot of cases where you're going to want to be able to parse through information in a file, and this is an awesome way to do it. So just to recap, whenever you want to open a file and read from it, you can just use this open function, type in the name of the file and then the mode, which in our case is going to be R. then you can do all sorts of stuff with it, and you always want to make sure that you close it when you're done. That's just good practice. So that's the basics of reading from files, and hopefully you guys can use this in some way, shape, or form in the future. In this tutorial, I want to talk to you about writing and appending to files in Python. So one of the cool things about Python is it allows you to work with external files. So I could have like an external text file, and I could actually like completely read all of the information in it. I could parse through it, use that information to do certain things. But in addition to reading a file, I could also write a file. And that's what I want to talk to you guys about today, is writing new files and appending onto existing files. Over here, I basically just have some code written out, and this essentially just reads information from this employees.txt file. So you can see over here, I'm specifying the mode, which is R, and that stands for read. And then down here, I'm just reading all of the contents of the file and spitting it out on the screen. So I'm gonna click the play button over here, and you'll see that this executes. So it's printing out all of the lines of code in our text file. So over here, I'm in this employees.txt file, and it just has all this information like employees in an office. But let's say that I wanted to add another employee onto here, right? Let's say that a new employee joined our company, so we wanted to add them onto this list. Well, I can come over here to my app.python file, and instead of reading from the file, I want to append to the file. So I want to say A. And appending to the file basically means that you're adding some text at the end of the file. So wherever the file ends, you're just going to add some text onto there. So what we can do is we can actually add another employee into the file. So instead of printing something out, I'm actually just gonna say employee file dot write. And when I say employee file dot write, I'm gonna be able to write something to the end of the file. So I can basically just write whatever I want. So why don't we add in another employee into our employees.txt file? So we can add in another employee. Why don't we say like Toby, and he's gonna be in human resources. So now when I run this program, it's gonna add Toby human resources onto the end of the file. So I'm gonna run my program, and you'll see that nothing shows up down here in the console. But if I go over to my employees.txt file, all of a sudden we have a new entry over here. It's Toby from human resources, right? So I was able to append a line onto the end of this file. But here's the thing, you need to be careful when you're writing to files because you can actually mess up a file very easily. For example, I already added Toby here into my file, but if I was to run this program again, you'll see that over here in this employees.txt file, it went ahead and added Toby again, right? So it added this employee here again. And also you'll notice that in this case, this employee didn't go on to the next line. I accidentally ran my file again, and all of a sudden it messed up this file over here. And so appending, you really need to be careful because if you accidentally run your file again, or if you append something on something wrong to the file, it's permanent, like it's getting saved inside of the file. So I want to talk to you guys a little bit more about, appending. Another thing we could do, let's say we wanted to add another employee, and you'll notice over here in this employees.txt file, when I appended it on again, it got appended to the end of the existing line, right? So the first time I had a new line there, but if you don't have a new line at the end of your file, and you want to add a new line, you're gonna have to add some special characters. So let's add another employee, and we'll call her Kelly. And let's just say Kelly is in customer service. So Kelly is gonna be in customer service. And if I want to add this employee onto the end of the file in a new line, I'm gonna have to put a new line character in front of it. So I can say \n, and this will append this entry into the file with a new line, so on a new line. So now when I run this, you'll see we get Kelly from customer service on her own line. So you wanna make sure that you're aware of like these special characters that you can use. They call them escape characters. And anytime you're adding onto a file, you want to make sure that you're adding on exactly where you want to add on. So in addition to appending to a file, I could also just like overwrite a file, or I could write an entirely new file. So since we already have this open, instead of appending to the file, why don't we just write a file? So I'm going to use this W. And now if I say employee file.write, because I'm using W and I'm not using A, it's actually gonna override the entire file, and it's only gonna put this inside the file. So when I run this and we go over to this employees.txt file, you'll see we only have one line inside of this file now. It's just Kelly customer service. That's because I was using W, not A. And when you use W, it's just overwriting everything that's in that existing file. You can also use W to create a new file. So over here, I could say employee file is equal to employees1.txt. And now what's gonna happen is when I run this, it's gonna create another file for me. So I'm gonna run this, and you'll see over here in my file browser, we have this new file, employees1.txt. So if I open this up, it has exactly the same stuff as in this employees file. But it basically created a new file for us. And so a lot of times you're gonna wanna create a new file, and you can use different extensions too. So if I wanted to create like a web page, I could say index.html, and I could also add in some HTML code in here. So if you don't understand HTML, don't worry about it. But if you do, I could put like a paragraph in here, another paragraph, like this is HTML. Basically HTML is like a web page. And the point I'm trying to make is that you could write out a web page inside of Python by doing something like this. So now when I played this, we get this index.html file, and it has some HTML inside of it. So that's one way that writing to files can be really useful. You can overwrite an existing file, you can write a new file and create it, or you can append on to the end of a file. And There's tons of applications for writing to files, and Python's a great language for working with reading, writing, and doing all that stuff with files. In this tutorial, I want to talk to you guys about using modules in Python. Now, a module is essentially just a Python file that we can import into our current Python file. So, for example, if I wrote a Python file that had a bunch of like useful functions or useful variables or other things like that, I could take that file, I could import it into the file I'm currently working on, and I could actually access all of those functions, all of those variables, all the stuff from that external file inside the file that I'm currently working on. So I'm gonna show you guys how we can use modules, and then we'll talk about where you can find awesome modules and really why modules make Python an awesome language. So over here in my text editor, I actually created this file, and it's called usefultools.python. And basically this file just has a bunch of sort of like useful tools that I might want to use in one of my programs. So you'll see over here I have some variables. This one is telling me how many feet are in a mile. This one's telling me how many meters are in a kilometer. And then we have this list here which lists out all of the members of the Beatles. I also have a couple different functions down here. So I have this get file extension function. And this basically just will, you give it a file name, it'll tell you what the extension is. And then we have this other function down here which simulates rolling a dice. So you pass it a number. If I pass it like a 6, it would roll a 6-sided dice. If I pass it a 9, it roll a 9-sided dice, etc. So this is like a Python file that I wrote, and it has some useful stuff in it. And honestly, there's a lot of stuff in here that I might want to use in the other Python files that I work with. So let's say I'm over here at this app.python file, and I'm thinking to myself, I think I could use one of those functions that was inside of that useful tools file. Actually, yeah, I need to simulate rolling a dice in my program. Well, instead of having to go over here, copy this function, and then paste it over here into my program, I can actually just import this useful tools file, and I'll be able to import all of these functions and all of these variables and attributes. So the way I can do that is just by coming up here, and I'm just gonna go right at the top of my file, and I'm just gonna say import, and then I wanna type in the name. name of the file that I want to import. So I'm just gonna say useful underscore tools. And Python's gonna be smart enough to know that it should go off and grab all the stuff from this useful tools.py file. So once I've used that import statement, I can actually use all of the functions inside of that useful tools file. So for example, I could simulate rolling a dice. I could say useful tools dot, and now I'm actually able to access all of the attributes from inside that file. So when I say useful tools dot, you'll see down here in my little suggestions menu, it's telling me like beetles, feet and miles, get file extension, meters and kilometers, roll dice. So it's giving me access to all of the stuff that was in that file. So over here I could just say like roll dice, and we could pass this like a 10. We'll roll a 10-sided dice, and now this should actually be able to run that function. So we'll simulate rolling a 10-sided dice. You can see we got 4. And this is a really core concept in Python, which is importing functionality from external Python files. And this is like huge in Python, and this is seriously going to change the way that you create your Python files. So you'll notice like I didn't have to copy any functions or any variables or anything over into this file, and yet I was able to use all the stuff that was inside this useful tools file. So that is huge, and honestly it's going to save you a lot of time because you can write something once and then you can import it into your other files. And so that's really the basics of using modules. I mean, modules are very simple. A module is just any external Python file that you want to use some stuff inside of it. I want to show you guys a place where you can go to find a huge list of modules. So I'm going to go over here to my web browser, and I'm on this website. It's actually like the official Python docs. And basically all I did to get here was just type in list of Python modules in Google. And depending on the version of Python you're using, you're going to want to make sure that you click the right one. I clicked on the version 3 one. And over here on this page, you can see there's just a huge list of Python modules. And these are basically modules inside of Python that you can just access. So essentially there's like all of this awesome code that's already been written for you. And so if there's some sort of functionality that you want to have inside of your Python program, chances are there's a module in here that has that functionality. So there's all sorts of stuff you can do. I mean, if you just look through this list, like you'll see a huge collection of basically just, you know, a bunch of either Python variables or Python functions, just, you know, things that you can use to make your programs better. So here's what I would recommend. Like, head over to this page and just sort of look through a lot of these different modules, you know, see what you can see. And honestly, like if you click on one of them, it'll bring you to a page that talks about like how to use it. It'll tell you like how to import it and just, you know, some basics about it. And this is sort of like the list that's on the official Python docs. But here's the other thing. The Python community is huge. There's tons of developers who use Python, and you can actually find a lot of third-party modules. So if you just go online and, you know, look up like Python module for doing X or Python module for doing Y, chances are somebody out there has already written a Python module to do what you're trying to do. So if you get good at using modules and you get good at, looking for them and finding them, you can actually save yourself a bunch of time, because chances are that somebody's already written a module to do, what you're trying to do, or like part of what you're trying to do. So now that we've taken a look at all these different Python modules, I want to just kind of dive in a little bit deeper into how we can actually use these things. So you'll notice here there's a lot of files, right? There's a lot of different modules that we apparently have access to in Python. But the question is, where are all these files stored, right? When I was over here in my program, for example, I was using this usefultools.py file. Like, I knew where that was. I created that file. I was directly involved in making it, and I just imported it over here. It was pretty easy, right? But what about all of these files, right? What about all of these modules over here? Like, where are all of these stored? And there's basically two types of modules here. There's built-in modules, which means they're just built into the Python language, so we kind of just automatically have access to them. And there's external modules. And a lot of these external modules are just stored in basically the same folder that we installed Python on our computer. So for example, let's look at a couple of these, right? We have like base64, BDB, bin ASCII. Like, if I come over here, and you'll see I'm over here in my little file explorer, I have my Python project, which is draft. There's also this other folder over here called external libraries. If I was to click down on this and I come down here, you can see it's just the version of Python that I'm using. There's a folder here called lib, and this is a very important folder. This is basically storing all of those external modules. So you can see if I scroll down here, we have all of these different like modules, right? So here's that base64, here's BDB, right? A lot of these external modules are stored inside of this lib folder. And like I said, there's external modules. There's also a few modules that are just like built-in modules. They're not going to be stored inside of here. And you can actually tell, so for example, if I was to come over here and click on base64, it tells me where the source code is. So the source code's in lib/base64. We were able to see that, right? I saw that inside of my lib folder. This bin ASCII though, for example, if I click on this, you'll notice that this isn't giving me a folder, because this is basically just like built into Python. So we don't have to worry about, locating that file. It's just kind of like, it just kind of works. So some of these are external, some of them are built in. And I want to show you guys, in addition to using these modules, right? So there's a lot of good stuff here. And honestly, you could spend, years and years just learning about all these different modules. But a lot of times you're going to want to use modules that other people have written. There's a lot of developers who work on Python and who write different modules. So there's a lot of useful modules out there that aren't included in this list, right? They're not going to be inside of this lib folder by default. And what we can actually do is we can install those external modules, those third-party modules that don't just come pre-installed with Python. And I'm going to show you guys how to do that really quick. So the first thing you need to do, obviously, is find a Python module that you want to install, that you want to download. And I have actually used one in the past, Python docs. It's an external module that you can use to basically use Python to create Word documents, which is pretty cool. So you can like format Word documents inside of it. So I'm just going to look that up here in Google. I'm just going to type in Python docs. And look, here's the thing. There's tons of these external modules. You don't have to use Python docs. I'm just giving you guys an example. But really, if you just look up like useful third-party Python modules, there's going to be lists of hundreds of these things online. In my case, though, Python docs has a website, and it basically just has like some installation instructions. So I'm going to come over here, and it tells me that I can install Python docs using the command pip install Python docs. So this brings us to something I want to talk to you guys about, which is pip. And pip is essentially a program. And actually, if you have a newer version of Python 3, it comes pre-installed with Python 3. And you can use pip to install Python modules. It's referred to as a package manager. And a package manager basically just allows you to like install, manage, update, and uninstall like different Python modules. So pip is extremely useful. And in order for us to install Python docs, we're gonna have to use pip. So I'm gonna show you guys how we can do that. What I wanna do is open up the command prompt or the terminal on my computer. If you're on a Mac, you wanna open up your terminal. If you're on a Windows computer, you wanna open up your command prompt. I'm using a Windows right now, so I'm just gonna come down to the search bar and type in CMD, and this command prompt should come up. So I'm gonna click this. Inside of the command prompt, we can actually use pip. The first thing we wanna do is just check to make sure that pip's installed. And like I said, if you have a newer version of Python 3, pip should come just pre-installed, and it should just work in here. If you don't have a newer version of Python 3 though, you might have to install pip separately. And there's tons of instructions online on how to install pip. So I'm just gonna check to make sure that I have it. I'm gonna type in pip -- version, and this should spit out the version of pip that I currently have. So as long as we have pip, then we're ready to install an external or a third-party Python module. All I have to do is just say pip install, and now I just want to type in the name of the Python module. So in the case of Python docs, it was just Python docs like that. Now again, you don't have to install Python docs. I'm just doing this for this tutorial just to kind of show you guys how this is going to work. But you know, what you want to do is go online and look up some third-party external Python modules. And generally, like I'd say 90 to 95% of the time, you're gonna be able to just install them using pip. In the off case that you can't install them using pip, chances are there'll be like some detailed installation instructions. But I would say for the most part, any like legitimate Python module is gonna be able to install using pip. So over here, I'm just gonna say pip install and then the module name, so Python-docs. And when I click enter, this is gonna go off and install Python docs for us. So I'm just gonna click enter, and it's gonna go off and install everything we need for Python docs. So you can see we successfully installed Python docs 0.8.6. So I'm gonna show you guys where exactly this got placed. So normally when we install a external third-party module, it's gonna get put inside of this lib folder. But it's gonna get put inside of a special folder in here called site package lib. Install a external third-party module. example, it's gonna get put inside of this lib folder, but it's gonna get put inside of a special tools.py file. Like, I knew where that was. I created that file. I was directly involved in making it, and I just imported it over here. It was pretty easy, right? But what about all of these files, right? What about all of these modules over here? Like, where are all of these stored? And there's basically two types of modules here. There's built-in modules, which means they're just built into the Python language, so we kind of just automatically have access to them. And there's external modules. And a lot of these external modules are just stored in basically the same folder that we installed Python on our computer. So for example, let's look at a couple of these, right? We have like base64, BDB, bin ASCII. Like, if I come over here, and you'll see I'm over here in my little file explorer, I have my Python project, which is draft. There's also this other folder over here called external libraries. If I was to click down on this and I come down here, you can see it's just the version of Python that I'm using. There's a folder here called lib, and this is a very important folder. This is basically storing all of those external modules. So you can see if I scroll down here, we have all of these different like modules, right? So here's that base64, here's BDB, right? A lot of these external modules are stored inside of this lib folder. And like I said, there's external modules. There's also a few modules that are just like built-in modules. They're not gonna be stored inside of here. And you can actually tell, so for example, if I was to come over here and click on base64, it tells me where the source code is. So the source code's in lib/base64. We were able to see that, right? I saw that inside of my lib folder. This bin ASCII though, for example, if I click on this, you'll notice that this isn't giving me a folder because this is basically just like built into Python. So we don't have to worry about, you know, locating that file. It's just kind of like, it just kind of works. So some of these are external, some of them are built in. And I want to show you guys, in addition to using these modules, right? So there's a lot of good stuff here. And honestly, you could spend, you know, years and years just learning about all these different modules. But a lot of times you're going to want to use modules that other people have written. And you know, there's a lot of developers who work on Python and who write different modules. So there's a lot of useful modules out there that aren't included in this list, right? They're not going to be inside of this lib folder by default. And what we can actually do is we can install those external modules, those third-party modules that don't just come pre-installed with Python. And I'm gonna show you guys how to do that really quick. So the first thing you need to do, obviously, is find a Python module that you want to install, that you want to download. And I have actually used one in the past, Python docs. It's a external module that you can use to basically use Python to create Word documents, which is pretty cool. So you can like format Word documents inside of it. So I'm just gonna look that up here in Google. I'm just gonna type in Python docs. And look, here's the thing, there's tons of these external modules. You don't have to use Python docs. I'm just giving you guys an example. But really, if you just look up like useful third-party Python modules, there's gonna be lists of hundreds of these things online. In my case though, Python docs has a website, and it basically just has like some installation instructions. So I'm gonna come over here, and it tells me that I can install Python docs using the command pip install Python docs. So this brings us to something I want to talk to you guys about, which is pip. And pip is essentially a program. And actually, if you have a newer version of Python 3, it comes pre-installed with Python 3. And you can use pip to install Python modules. It's referred to as a package manager. And a package manager basically just allows you to like install, manage, update, and uninstall like different Python modules. So pip is extremely useful. And in order for us to install Python docs, we're gonna have to use pip. So I'm gonna show you guys how we can do that. What I wanna do is open up the command prompt or the terminal on my computer. If you're on a Mac, you wanna open up your terminal. If you're on a Windows computer, you wanna open up your command prompt. I'm using a Windows right now, so I'm just gonna come down to the search bar and type in CMD, and this command prompt should come up. So I'm gonna click this. Inside of the command prompt, we can actually use pip. The first thing we wanna do is just check to make sure that pip's installed. And like I said, if you have a newer version of Python 3, pip should come just pre-installed and it should just work in here. If you don't have a newer version of Python 3 though, you might have to install pip separately. And there's tons of instructions online on how to install pip. So I'm just gonna check to make sure that I have it. I'm gonna type in pip --version, and this should spit out the version of pip that I currently have. So as long as we have pip, then we're ready to install an external or a third-party Python module. All I have to do is just say pip install, and now I just want to type in the name of the Python module. So in the case of Python docs, it was just Python docs like that. Now again, you don't have to install Python docs. I'm just doing this for this tutorial just to kind of show you guys how this is going to work. But what you want to do is go online and look up some third-party external Python modules. And generally, like I'd say 90 to 95% of the time, you're going to be able to just install them using pip. In the off case that you can't install them using pip, chances are there'll be like some detailed installation instructions. But I would say for the most part, any like legitimate Python module is going to be able to install it using pip. So over here, I'm just going to say pip install and then the module name, so Python-docs. And when I click enter, this is going to go off and install Python docs for us. So I'm just going to click enter, and it's going to go off and install everything we need for Python docs. So you can see we successfully installed Python docs 0.8.6. So I'm going to show you guys where exactly this got placed. So normally when we install a external third-party module, it's going to get put inside of this lib folder. But it's going to get put inside of a special folder in here called site packages. So site packages is a special folder, and if I open this folder, you'll see now we have this docs folder, and we also have this Python docs 0.8.6 py3.6.egg info folder. So these two folders are basically included in that module installation. So you can see this docs folder has a bunch of different Python files and has a bunch of stuff in here that we can use. So if I wanted to use this inside of one of my programs, I'm just going to refer to the name of the module. So in our case, it's just going to be docs. So I used Python docs in order to install it, but we're going to use docs if we want to import it. So I could come up here and I could say import docx, and now I can actually use it. So I can just say like docs dot whatever, and you can see there's a bunch of different stuff down here. There's like a document part, image part. There's a bunch of stuff that we can use with this, and obviously depending on the Python module you install, there's going to be different instructions. But you can see it got stored down here in this site packages folder. If I wanted to remove this, I could use pip to do it. So I could just say pip uninstall, and we could just again say the module name, so Python docs, and pip will now uninstall this on our computer. So if I was to go back over to this folder, you'll see that those two, that docs folder and then that other folder disappeared. So they're no longer here, and I'm actually not going to be able to use this anymore. So that's sort of the ins and outs of using modules. Now again, there's tons of these modules, and I can make dozens and dozens of Python courses covering each one of these modules. The built-in modules, the modules that are included by default, and external modules. There's tons of these things out there. And really, as a Python programmer now, what you can do is you can go out and play around with these different modules. I showed you the ins and outs of installing them, and you can use pip to install all these different modules. And you can make sure that you have them by checking the site packages folder or the libs folder. But really now it's on you to just kind of go out and use these modules, and don't shy away from this, because modules are a huge part of Python, and you're definitely going to want to include them in your Python stack. In this tutorial, I want to talk to you guys
I am within transition.
You're within transition.
Yes.
In this tutorial, I want to talk to you guys about classes and objects in Python. Now, classes and objects are extremely useful in Python programming, and they can help you to make your programs more organized and more powerful. So when we're in Python, we're dealing with all types of data, right? And a lot of times when we're writing programs, we're going to have to work with different types of data. And there's essentially like a few basic types of data we can deal with, usually things like strings, so like plain text, numbers, and Boolean values. Those three are kind of like the main types of data that you're going to be working with in Python. And we have all sorts of structures we can use to store that data, things like lists or dictionaries. But here's the problem, is that not all information, not all data, not all things can be represented using strings, numbers, or Booleans, right? There's a lot of things in the real world that we can't represent in something like a string or just a number, right? In other words, think of something like a phone or a computer or a person, right? You can't really represent those things in like a string or a number, In other words, like the data types that we have available to us in Python can't cover that. And so what we can do with classes and objects is we can essentially create our own data types. So I can create my own data type for anything I want in Python. So I could create like a phone data type, and it could represent a phone. So I could store all the information I would ever want to know about my phone inside of that data type. And in Python, we could create a class for it. And essentially what a class is it's just saying, hey, here's another data type that we want to use in Python. So with a class, you can essentially define your own data type, and it's super awesome. And classes are extremely useful. Classes are used in almost every single major programming language out there. So in this tutorial, I just want to give you guys a basic introduction of classes and using them inside of Python. So let's say that I'm writing a program and I want to represent a student inside of this program. So maybe I'm writing a program for like a college or a university. Let's say that in this program, I want to model a student. Like I want to model a real world object and I want it to be a student, right? Well, we don't have a student data type, and I can't really represent a student in just a single string or a number. So what I can actually do is I can create a class for a student, and I'm basically creating like a student data type. So I'm going to show you guys how we can do that and create our student class. So over here, I'm just going to make a new file. We'll just make it a new Python file. So I'm just going to call it student.py. And inside of this student.py file, I want to create a student class. So the way that I can do that is just by typing class. And now I want to type the name of the class that I want to create. So in our case, we're going to create a class called student. So I'm just going to say student, and now we're going to make a colon. Now everything that goes inside of here is going to be inside of our student class. So everything that's indented like this will be considered a part of our student class. And basically what we can do inside of this student class is we can define a bunch of attributes about a student. So essentially what I'm doing is I'm like modeling a student. I'm creating our student data type. And I can use things like strings, integers, and Booleans in order to map out what a student should be and what a student should have. So I want to create something called an initialize function. And the way I do that is just by typing out def, and I'm just going to type 2 underscores, and then the word init, and then 2 more underscores. And you also want to type out open and close parentheses, and inside of those parentheses we want to type out self, and then we want a colon after that. What I can do inside of this initialize function is I can basically map out what attributes a student should have. So we can essentially define like, hey, here's the student data type in Python. So what I want to do is add in certain attributes after this self. So I'm just going to say self, a comma, and now we can start thinking about, what values will represent a student inside of our Python program. So if I'm thinking something like name, right? So every student in our program should have a name. They also might want to have a major because they're in college. They probably also will have a GPA, so their grade point average, like how they're doing in school. And let's define one more thing. Let me think. Why don't we make a Boolean, and it's going to be called is on probation. And this will basically tell whether or not the student is on probation. So essentially what I'm doing inside of this initialize method, inside of this init function, is I'm defining what a student is in our program. And so in this program, a student has a name, it has a major, it has a GPA, and it has a value that determines whether or not it's on probation. This right here is the student data type. So if I'm representing a student inside of my program now, it has all of these attributes associated to it. And that's basically what I'm doing up here. Now, inside of this initialize function, we actually have to do something, and basically what I want to do is assign some values. So I'm going to be writing out some stuff, and this might not make total sense right now, but this is going to make sense in a second after we create our first student object. So just stick with me right now and just basically know that we have to do what I'm doing over here. So I'm just going to say self.name is equal to name, and then I'm going to say self.major is equal to major, self.gpa is equal to GPA, and I'm going to say self.is on probation is equal to is on probation. So again, this might not make a whole lot of sense right now, but in a little bit, this is gonna make total sense. So now that I have this student class defined, I can actually use this class inside of my other files. So I'm gonna come over here into this app.python file, and this is just my main file. And so I actually wanna create a student, right? So in that student class, we defined the student data type. And we basically said like, hey, a student has a name, a major, a GPA, and it says whether or not they're on probation. That's like the template for what a student is. But we can actually create a student. So we can create an actual student and give it some information. And that's called an object. So this student class over here is basically defining what a student is. So a class is just like an overview of what the student data type is. An object is an actual student. So it's an actual student with a name, a major, and a GPA. It's not just this template anymore, it's actually like a student that we're representing inside of our program. So in order to use that student class and create a student object, I actually need to import that. So all I have to do over here is just say from student, and this is referring to this student file. I can say import student. And basically what this is saying is from the student file, I want to import the student class. So even though these are both student, they're referring to different things. So this is referring to the file, and this is referring to the actual student class. So now that we did this, we can create a student. So you can create an object of a class a lot like you would a normal variable. So I can just give it a name. I'm gonna call this student1, and I'm just gonna set it equal to student, and I'm gonna make an open and close parentheses. And now inside of this parentheses, I wanna give this student a name, a major, a GPA, and an is on probation value. So I'm gonna say, we'll just create a fake student. So I'll just say his name's Jim, and he's studying business, and we wanna give him a GPA, so maybe he has like a 3.1. And finally, we want to say whether or not this student is on probation. So why don't we say false? So basically what I'm doing is I'm saying that I want to create a student. So I want to actually create a student object. And remember, an object is just an instance of a class. So the class is like an overall template. It defines what a student is. But an object is an actual student with actual information. So we could call student1 now, this is a student object. So I just want to show you guys what this student object actually is and what we can do with it. And then I'm going to talk some more about that init function from before. So over here, I'm just going to, this for example, so you can actually represent GPA. It's not just this template anymore, it's actually like a student that we're representing. representing inside action. And that is basically the object. Create an student class inside of my other files. So and I can actually make and this probation self name I do. So if inside of this, so what values and a student should be and what a student should have. So I want to create something called an initialize function. And the way I do that is just by typing out DEF, and I'm just going to type 2 underscores and then the word INIT and then 2 more underscores. And you also want to type out open and close parentheses, and inside of those parentheses we want to type out self, and then we want a colon after that. What I can do inside of this initialize function is I can basically map out what attributes a student should have. So we can essentially define like, hey, here's the student data type in Python. So what I want to do is add in certain attributes after this self. So I'm just going to say self, a comma, and now we can start thinking about, what values will represent a student inside of our Python program. So if I'm thinking something like name, right? So every student in our program should have a name. They also might want to have a major because they're in college. They probably also will have a GPA, so their grade point average, like how they're doing in school. And let's define one more thing. Let me think. Why don't we make a Boolean, and it's going to be called is on probation. And this will basically tell whether or not the student is on probation. So essentially what I'm doing inside of this initialize method, inside of this init function, is I'm defining what a student is in our program. And so in this program, a student has a name, it has a major, it has a GPA, and it has a value that determines whether or not it's on probation. This right here is the student data type. So if I'm representing a student inside of my program now, it has all of these attributes associated to it. And that's basically what I'm doing up here. Now, inside of this initialize function, we actually have to do something. And basically what I want to do is assign some values. So I'm going to be writing out some stuff, and this might not make total sense right now, but this is going to make sense in a second after we create our first student object. So just stick with me right now and just basically know that we have to do what I'm doing over here. So I'm just gonna say self.name is equal to name, and then I'm gonna say self.major is equal to major, self.gpa is equal to the GPA, and I'm gonna say self.main file template student data. I need to import from the student. All I have to do over here is just say from student, and this is referring to this student file. I can say import student. And basically what this is saying is from the student file, I want to import the student class. So even though these are both student, they're referring to different things. So this is referring to the file, and this is referring to the actual student class. So now that we did this, we can create a student. So you can create an object of a class a lot like you would a normal variable. So I can just give it a name. I'm gonna call this student1, and I'm just gonna set it equal to student, and I'm gonna make an open and close parentheses. And now inside of this parentheses, I want to give this student a name, a major, a GPA, and an is on probation value. So I'm gonna say, we'll just create a fake student. So I'll just say his name's Jim, and he's studying business, and we want to give him a GPA. So maybe he has like a 3.1. And finally, we want to say whether or not this student is on probation. So why don't we say false? So basically what I'm doing is I'm saying that I want to create a student. So I want to actually create a student object. And remember, an object is just an instance of a class. So the class is like an overall template. It defines what a student is, but an object is an actual student with actual information. So we could call student one now, this is a student object. So I just want to show you guys what this student object actually is and what we can do with it. And then I'm going to talk some more about that init function from before. So over here, I'm just going to make a print statement. And inside of here, I just want to print out student. And what's cool about this student one object is I can actually access each of the attributes from inside of this object. So if I wanted to get the name of the student, I could say student1.name. And now this is actually going to print out the student's name. So over here, you'll see it prints out Jim. If I wanted, I could print out the student's GPA, and it's going to print out the student's GPA, 3.1. So now that I created this student object, I can actually access the information about the student. So essentially, I've just created a student data type. So I could create as many of these students as I wanted. If I wanted, I could create another student. We could call it student2. And essentially, we do the same thing. We just give it different information. So we could say like, Pam, and her major is art, and she has like a 2.5, and let's say that she is on probation. So now I have another student, student 2. So if I wanted, I could access information about that student. We could say like student2.gpa. And now this is giving me the GPA of student 2. So basically what I did was I created a student data type, and I created student objects, and now I'm able to represent a student inside of my program. So let's talk real quick about all this stuff over here, because I didn't really explain it. Basically what's happening is when I come over here and I say student, and I'm passing in all of these different values, those are getting passed into this init function. So remember, I passed in a name, I passed in a major, I passed in a GPA. When we create that student, we're actually calling this function. And when I pass in the name, the major, and the GPA, those values are actually getting stored over here in this name, this major, this GPA, etc. Right? So I'm giving this student object all of that information. And down here, what I'm doing is I'm saying self.name is equal to name. And basically what this means is the actual object's name is going to be equal to the name that they passed in. So self.name is an attribute of student, right? So the student is storing a name, the student is storing a major, the student is storing a GPA. But that's different from this name, this major, and this GPA. Remember, these are all just values that I passed in. They're just parameters. And so I need to take the values that I passed in and I need to assign them to the actual attributes of the object. So I need to say, okay, the name of the student is going to be equal to the name that we passed in. One more time. The name of the student object is going to be equal to the name that we passed in. The name of the student's major is going to be equal to the major that we passed in. The student's GPA is going to be equal to the GPA that we passed in. That's basically what's happening here. So when I say self, it's referring to the actual object. So over here, when I'm creating this student object, I'm giving it all of this information. It's taking that information and storing it as attributes for the object. So hopefully that makes sense. I think that's about as clear as I can make it. But the point is that now we have a student data type. So now I can represent a student inside of my Python program. And that's like super powerful. And what's cool about classes and objects is you can do this with anything. So in this example, we created a student class and then we created student objects off of that. But I could model any real world entity into this program. I could model something like a phone, or I could model like a water bottle, or I could model, a keyboard, right? I could model anything that I wanted inside of my program. I could just give it certain attributes, right? And so that's what's cool about classes is we can model real world objects and we can create our own data types. In this tutorial, I'm gonna show you guys how to build a multiple choice quiz in Python. So basically we're gonna set up a little multiple choice quiz and we'll have the user take the quiz, and as they take the quiz, we'll keep track of their score, and then at the end we'll tell them how they did. So this is gonna be a pretty cool video. I'm excited to show you guys how to do this, and we'll get to use things like classes and if statements and loops in order to build this program. So we're gonna use a lot of cool stuff in Python. The first thing I want to show you guys, I actually did this before I started the video. It's this little array, it's called question prompts. And I basically just wrote out all the questions that are gonna be, or I shouldn't say the questions, I wrote out all the question prompts that are gonna be inside of my multiple choice quiz. So the first one just says, what color are apples? And the answers are red, purple, or orange. The next one is, what color are bananas? The options are teal, magenta, and yellow. And the third question is, what color are strawberries? And the options are yellow, red, and blue. So this is obviously a very, very easy multiple choice quiz, but I just kind of wrote out the questions beforehand so I didn't have to spend time doing that. So let's talk about how we can build a multiple choice test. Well, the first thing I want to think about is, how can I represent the questions in the test, right? Over here we have the question prompts, but there's actually two parts to a question when you think about it. There's the prompt, in other words, like the actual question itself, and then there's the answer to the question. And both of those attributes need to be kept track of, right? I need to keep track of what we want to ask, and I need to keep track of what the answer is. So what I'm actually gonna do is create a question class. So I'm gonna create a little data type for questions, and inside of that question class, we'll be able to store the question prompt, and we'll also be able to store the question's answer. So I'm just gonna come over here to my folder, and I'm gonna make a new Python file, and we're just gonna call this question.py. So we'll call it question.py. And inside of this question.py file, I'm gonna make a class. So I'm just gonna say class question, and I'm gonna put a colon here. So inside of this question class, we wanna define it in initialize function. So I'm gonna say def 2 underscores init 2 underscores, and then we're gonna type out an open and close parentheses, self, and then a colon. So after this self, we wanna define the different attributes that will describe or that will be included in a question. So we're gonna include a prompt, and we're gonna include an answer. So every question will have a question prompt and a question answer. Now down here, I want to take those values and assign them to the actual class object. So I'm going to say self.prompt is equal to prompt, and I'm going to say self.answer is equal to answer. So now we have a question class set up, and we can store all the information we need about a question. So what I want to do now is go back over to my app.python file, and we're actually going to create an array of questions. So I have over here these 3 prompts, and I'm actually just gonna create another array. So we'll just call it questions, and I'm just gonna set it equal to 2 open and close square brackets, and we're gonna start creating question objects. So I can just say the first element in this questions array will be a question, and we wanna pass question prompts 0, and the answer to the first question was A, red, green. That's the color of apple. So I'm going to pass that first question, and I'm also going to pass the answer, which is A. And you'll see down here I'm getting an error, so it's saying unresolved reference question. So actually what we need to do before we can create these questions is we need to import this question class. So I'm going to come up here and say from question import question. So now down here in this questions array, we're not getting that error anymore. So we created one question object, and I'm just gonna create a couple more for these other ones. So I'm just gonna copy this one, and we will paste this down here. All right, so now we're creating 2 other questions, and these ones are gonna be 1 and 2. And the answer to the second question is C. And the answer to the third question, I think it's B. Let me look. Yeah, so it's C and B. All right, so essentially what we're doing is we're creating 3 questions. Each one is getting a different question prompt, and they're each getting different answers. So now we have an array of questions that we want to ask. and they're each 1. All right, so now we're creating two other questions, and these ones are going to be 1 and 2. And the answer to the second question is C. And the answer to the third question, I think it's B. Let me look. Yeah, so it's C and B. All right, so essentially what we're doing is we're creating 3 questions. Each one is getting a different question prompt, and they're each getting different answers. So now we have an array of questions that we want to ask on our test. So the next step is to actually write a function that will run the test, right? It has to ask the user the questions and it has to check to see if they got the answer right. So down here, lower in the file, let's create a function. So I'm just gonna say def, and we'll call this run test. And inside of this parentheses, we're gonna take one parameter into this function. We're gonna take a list of questions. So I'm just gonna say questions. So this is basically gonna be a list of question objects that we wanna ask the user. So once I'm in here, all I wanna do is loop through all the questions. So I wanna loop through each question, I wanna ask it to the user, I wanna get the user's answer, and I wanna check to see if it's right. And we need to be able to keep track of how the user does through the test. So I wanna create a variable called score. And I'm just gonna set it equal to 0. So every time the user answers a question right, we'll increment this score variable. All right, so what I wanna do is, like I said, loop through all the questions in that questions array. So I'm gonna create a for loop. I'm gonna say for question in questions. So in other words, for each question object inside of this questions array, I wanna do something. And basically, the first thing I wanna do is ask the user the question. And I wanna store their response inside of a variable. So I'm gonna make a variable down here called answer. And this is gonna represent the user's answer to the question. And I'm gonna set it equal to input, and I need to give this a prompt. So I'm actually gonna give this the prompt for the question. So I can just say question.prompt. So now I have the answer that the user entered in, which is stored inside this variable. So we want to check to see if they got the question right. And I can do that using an if statement. So I can say if answer, and this refers to the student's answer, is equal to question.answer. So I'm checking to see if the answer that the student gave is equal to the answer of the current question that we're asking. And if this is true, then I just want to increment score. So I'm gonna say score plus equals 1. And this basically just means we're adding 1 to the score. So the last thing I want to do inside of this function is just print out the result. So I want to print out how the user did. So down here, I'm just gonna say print, and I'm basically just gonna print out like, hey, you got like 2 out of 3 questions, or you got 5 out of 6 questions right, or you got 0 out of 10 questions right. We'll just print out how they did. So I'll just say you got, and now I wanna print out how many questions they got right. So this is just gonna be the score. And in order to print a number alongside of a string like this, I'm gonna have to say str and then type in the number. So we'll say str score. So we'll basically say you got however many they got right out of, so we'll use this little /, and now we'll just say how many questions there were. So we can say, and again, we're gonna have to convert this to a string because it's gonna be a number. So we can say string, and then we wanna figure out how many questions were in that questions array. So I can say len, and inside of here, we can just say questions. So this is kind of like this long statement just to print out how many questions there were. So then over here, I'll just say correct. All right, so now we have this print statement, and it's just gonna be printing out how many questions they got right. So let's see if this works. The last thing I need to do is just call this run test function. So I'll say run test, and I'm just gonna pass it that questions array that we created before. So we created this questions array with all of these question objects inside of it. I'm basically just gonna pass that into this run test function. So now let's run our program and see how we did. Hopefully we don't get any errors. There's a lot of code there, so it's possible that we might. Okay, so it says, what color are apples? This is a tough one. All right, let's put A, so we'll get the first question right. What color are bananas? Let's get the second question wrong. So I'm gonna say B, bananas are magenta. And we'll get the third question right. So it says, what color are strawberries? I'll just put B because that's the right answer. So now you'll see that our program prints out, you got 2 out of 3 correct. So not only did it ask us all the questions and get our input for each question, but it also kept track of our score and it printed it out. So why don't we run through the test one more time, and we'll just like get 2 wrong this time. So I'll get this one wrong, I'll get this one wrong, and I'll get this one right. So now it says you got 1 out of 3 correct. So it's able to actually grade our test. And what's cool about the program we just wrote is if I wanted, I could add another question into here and it would automatically be able to ask it. So it doesn't matter how many questions we put in here, it's just able to ask it. And so really the point I was trying to make with this whole video was just how we can use something like a class in order to model a real world entity. So for example, we created this question class, and we were able to store all the information about a question that we could ever need. So we were able to store like the prompt and the answer. So we created our own question data type, and then we were able to create a bunch of different questions, pass it into this run test method, and it was able to grade the test and just run the test really easily. So that's kind of the point. So hopefully this makes sense. You know, this was a lot of code, so if you don't fully understand what I did, go back, watch the video, you know, try it a couple times on your own and see if you can create your own multiple choice test. In this tutorial, I want to talk to you guys about class functions in Python. So a class function is essentially a function that we can use inside of a class, and it can either modify the objects of that class or it can give us specific information about those objects. Over here, I have this student.py file. And inside of here, I created a student class. So I just had a class student, and I gave this student a couple of different attributes. I gave it a name, a major, and a GPA. So I can give this student all of this information. So when I create a student object, it'll have all of that information in it. Now over here on this app.py file, it actually created two students. So student 1 is Oscar, who's studying accounting, and he has a GPA of 3.1. Student 2 is Phyllis, who's studying business, and she has a 3.8. So what we can actually do is we can use functions inside of these class files. So I could actually define a function inside of this student class, and then all of my student objects could access it. So for example, I could come down here and create a function, and let's say we wanted to create a function that told us whether or not this particular student had honors. So whether or not they were on the honor roll, right? Basically, like, are they like a really good student? So I could define a function called on honor roll, and basically what it's gonna do, it's going to tell me whether or not this particular student is on the honor roll. And let's basically just say the rules for being on honor roll is you have to have a GPA of 3.5 or above. So if your GPA is 3.5 or above, that means you're on the honor roll. Well, over here, I could actually write the code for that. So I could say if self.gpa, and when I say self over here, this is referring to like the actual student's GPA. And you'll notice over here, I have to pass that in as a parameter, and that always has to be the first parameter. So I could say if self.gpa is greater than or equal to 3.5, then we can return true, because this student is on the honor roll. Otherwise, else, we can just return false, because if their GPA isn't above a 3.5, then they're not on the honor roll. So that's essentially our little on honor roll function. And you can see it's a very small function, but it provides a service to the objects of this class, right? It allows the objects of this class to figure out whether or not that current student is on the honor roll. So over in this app.py file, I could just print out that value. So I could say print, and I'm gonna see if student 1 is on. on the honor roll. So now when I run this, you'll see it should print out false. And it's printing out false down here because student 1 only has a GPA of 3.1. If I was to do the same thing on student 2 has a GPA of 3.8, so we should return true. And that's exactly what happens. So essentially a class function is just a little function that can be used by the objects of the class. And I would say this is a pretty good example of like what a class function should be doing. It should be like giving us information about the class, or it could also be like modifying information about the class. And so that's the basics of using functions in classes. I mean, this is a pretty simple tutorial, but I really just wanted to introduce you guys to the concept of putting functions inside of classes. This is going to be really useful, and if you're making a class, you always want to think about like what functions can I put inside of here that will, essentially help the user to either figure out information about the object or modify different values in the object. In this tutorial, I want to talk to you guys about inheriting GPA of 3.8. If I was here, I essentially our little on honor roll function, and you can see it's a very small function. Function, but it provides actually our of a 3 and just returns on the PA as a parameter. Yeah, and we cover above honor roll. And I have to is print out false, and it's printing out false. Down here, now when I want that's essentially our little on 5 GPA, and we can false because so that's essentially our little on honor roll function, and you can see it's a very small function, but it provides a service to the objects of this class, right? It allows the objects of this class to figure out whether or not that current student is on the honor roll. So over in this app.py file, I could just print out that value. So I could say print, and I'm gonna see if student 1 is on the honor roll. So now when I run this, you'll see it should print out false. And it's printing out false down here because student 1 only has a GPA of 3.1. If I was to do the same thing on student 2 has a GPA of 3.8, so we should return true. And that's exactly what happens. So essentially a class function is just a little function that can be used by the objects of the class. And I would say this is a pretty good example of like what a class function should be doing. It should be like giving us information about the class, or it could also be like modifying information about the class. And so that's the basics of using functions in classes. I mean, this is a pretty simple tutorial, but I really just wanted to introduce you guys to the concept of putting functions inside of classes. This is gonna be really useful, and if you're making a class, you always want to think about like, what functions can I put inside of here that will, essentially help the user to either figure out information about the object or modify different values in the object. In this tutorial, I want to talk to you guys about inheritance in Python. Now, inheritance is basically where we can define a bunch of attributes and functions and things inside of a class, and then we can create another class and we can inherit all of those attributes. So I could basically have one class that has all the functionality of another class without having to physically write out any of the same methods or attributes. So if that's confusing, don't worry. I'm gonna show you guys exactly what this is in this video. So let me show you about some stuff I have set up over here. I created this class called Chef. And over here we just have this class Chef. And inside of this Chef class, we have 3 functions. So this Chef can do 3 things. The Chef can make chicken, the Chef can make salad, and the Chef can make a special dish. And whenever the Chef makes a dish, he basically just says, the Chef makes a chicken, or the Chef makes a salad, or the Chef makes barbecue ribs. For this special dish, it's basically just saying whatever the Chef is doing. So if I was to come over here to my app.python file, you'll notice that I'm importing the Chef. So I'm basically allowed to use this Chef class now, and I can say my Chef is equal to Chef. So I'm creating a new Chef. So now if I came down here and I said my Chef dot make chicken, when I run my program, now it's gonna say the Chef makes a chicken. If I said make special dish, and I run the program, now it's gonna say the Chef makes barbecue ribs, right? Because that's the Chef's special dish. So I have this really awesome Chef class and it works really well. But let's say that I wanted to create another class to model another type of chef, right? So this Chef class is just modeling like some generic chef, right? We're representing some generic chef in our program. But let's say that I wanted to create a class that modeled a different type of chef. For example, let's say we wanted to create a class that modeled a Chinese chef. So instead of just a normal chef, this is a Chinese chef. Well, I actually created a file over here called ChineseChef.python. So we could actually use this ChineseChef.python file to create our Chinese chef class. So I'm just gonna say class, and over here I'm just gonna say Chinese chef, and basically I just can define everything that the Chinese chef can do. But let's say that our Chinese chef can do everything that our generic chef can do. So the Chinese chef is like a special chef, right? It's a very specific type of chef. But let's say that this Chinese chef can do everything that the normal chef can do. So the Chinese chef can make chicken, can make salad, and can also make a special dish. Well, if I wanted to give this Chinese chef all of that functionality, I could just come over here and I could copy all of these functions and I could paste them in here. And so now the Chinese chef can do everything that the other chef can do. But let's say that in addition to all of these things, the Chinese chef can also make a special dish called fried rice. So I could say def, and we could say make fried rice. So the Chinese chef has this extra function which allows it to make fried rice. And over here we could just say the chef makes fried rice. And let's also say that the Chinese chef has a different special dish. So instead of making barbecue ribs, the Chinese chef makes orange chicken. All right, so now we have our Chinese chef class set up, and you'll notice that it can do everything that the normal chef could do. So let's go back over to our app.python file, and I want to create a Chinese chef object. So instead of importing from chef, we're gonna just import from Chinese chef. So I'll say Chinese chef, and we're gonna import Chinese chef. So let's go ahead and make a Chinese chef object. So down here, I'm gonna make one, and I'll just say and then my Chinese chef, we can print out this Chinese chef a chef could do. So let's go. And you'll notice that it can do everything that the normal chef could do. So let's go back over to our app.python file, and I want to create a Chinese chef object. So instead of importing from chef, we're gonna just import from Chinese chef. So I'll say Chinese chef, and we're gonna import Chinese chef. So let's go ahead and make a Chinese chef object. So down here, I'm gonna make one, and I'll just say and then my Chinese chef, we can print out this special dish. So remember, the Chinese chef can do everything that the normal chef could do. So if I say my Chinese chef dot make special dish, when I run this program, you'll see the regular chef is making barbecue ribs and the Chinese chef is making orange chicken. So everything works out. And this Chinese chef also has an extra method called make fried rice, and you can also make fried rice. But here's the problem, right? When I go over here to this Chinese chef.py, when I wanted to use all of the functionality that was inside this chef class, I actually had to copy and physically paste all of these functions down into this file, right? And that's kind of a drag. I mean, especially like, imagine if this chef had like 20 or 30 of these different functions in it. Well, I'd have to copy and I'd have to paste all of those inside of this Chinese chef. And this is where we can use something called inheritance. So instead of having to copy and paste all of these functions, I could just inherit these functions from that chef class. And in order to do that, I can actually just get rid of all of these, and I can come over here, and right next to where I'm saying class Chinese chef, inside of parentheses, I can say the name of the class that I want to inherit from. So I could just say chef. And I'm also gonna have to import this. So I'm gonna come over here and we'll say from chef, import chef. So basically what this is saying is inside of this Chinese chef, I wanna be able to use all of the functions that are contained inside of the chef class. So I'll say that one more time. Inside of this Chinese chef class, I wanna be able to use all of the functions that are inside of this chef class. So by using inheritance here, I'm actually able to come over here to this app.py file, and now I'm still able to execute, for example, like the make chicken function. Even though I didn't specify the make chicken function in here, I didn't write it out, I can still run this program, and the Chinese chef will still be able to make chicken. So when I run this program, you'll see down here it says the chef makes chicken. And that's because I inherited the make chicken method from the chef class. But here's one thing that got messed up. If I come over here and I say make special dish, remember the Chinese chef special dish was supposed to be orange chicken, but now the Chinese chef is gonna be making barbecue ribs because I inherited this make special dish function from this chef class. And so what I can actually do is I could come in here and I could override that make special dish class. So I could say def make special dish, and down here I can just override it. So I could say the chef makes orange chicken. And now when I go over here and I run this make special dish function, now the chef's gonna be back to making orange chicken. So the Chinese chef will make his special dish. So that's basically what inheritance does. It allows me to inherit functionality from an existing class into the new class, and I can actually just inherit all of it without having to write it out. So I didn't have to write out make chicken and make salad inside the Chinese class, but the Chinese chef can still make chicken and salad because it inherited that functionality from the chef class. In this tutorial, I want to talk to you guys about the Python interpreter. The Python interpreter is basically a little environment that we can use to execute Python commands. So it's kind of like this little sandbox environment where we can test out and try out different Python commands or different Python functions in a very safe and neutral environment. So it's kind of like a quick and dirty way to write Python and try different things out. And the way we use the Python interpreter is by opening up our command prompt. Now, if you're on Windows, there's a program called Command Prompt. If you're on Mac, there's a program called Terminal. And basically, you need to open that program in order to use the Python interpreter. So I'm here on a Mac, but if you're on a Windows, you can essentially do exactly what I'm doing just inside of the command prompt. So on Mac here, I'm just gonna search for my terminal. If you're on Windows, you can just search for like CMD or command prompt and it should pop up. So the terminal is basically an environment on our computer where we can interact with the computer and do different things without a graphical user interface. So normally when we interact with the computer, we're using things like buttons or windows, and where we can move stuff around. We can basically just like interact with the computer with graphics. But the terminal or the command prompt is a place where we can interact with the computer using text commands. So I'm not going to get too much into what the terminal and the command prompt are, but that's essentially what it is. So inside of here, we can use the Python interpreter. And the Python interpreter is basically just a little program that, like I said, we can write, sort of Python in. So generally, all you have to do is go over to your terminal or your command prompt and type in Python 3. And since we're using Python 3, I'm gonna type Python 3. But you can also just type normal Python, and I'm pretty sure that gives you Python 2. Now, here's a quick disclaimer. On Windows, you may run into a problem where you can't use this Python 3 command, and it's possible that if you're running into that problem, Python 3 hasn't been added to your Windows path variable. And basically what that means is your computer doesn't recognize the command Python 3. If that's the case, all you have to do is just go and Google how to add Python 3 to your Windows path variable. It's really easy. I'm not going to get into it in this video just because it's kind of outside the scope, but if you're running into that problem, that's probably it. It's not on your Windows path variable. So just Google around for that and you should be able to find an answer. But I'm gonna type Python 3 and I'm gonna click enter, and it's gonna open up this cool little thing down here. So you can see it basically just says like, here's the version of Python. Now, I'm just gonna enter so we can have some like new lines here. But down here, this is the Python interpreter. So we can write Python code in here and it's gonna work. So I could, for example, I could write like print, and inside of here I could print like hello world. And when I click enter, you'll see that it prints out hello world. I could create a variable. So for example, I could say like num1 is equal to 10. I could say num2 is equal to 90. And then I could print out num1 plus num2, and it's gonna be able to do that for me. I could also use something like a function. So I could define a function in here. We could make a function that's called say hi, and it'll take a name parameter. And you'll see here, when it saw I wanted to create a function, it put these 3 little dots, and I can indent in and we can write the code for our function. So I could say like print hello plus name. And now I have a function called say hi. So I can break out of this by just entering again. And I can call the function. So I could say hi, and we'll say hi to me. Hi, Mike. So now it's gonna say, hello, Mike. So I can use a function. I could use something like an if statement, you know. I could say, I could use something like a for loop. We could use while loops. I mean, we can basically use all of the basic like Python commands and, you know, inside of this Python interpreter. And like I said before, it's essentially just an environment where you can test out Python code. Now, this is not a place where you want to write like any serious Python scripts. So if you're like designing and writing a Python program, I would not recommend doing it inside of this interpreter. It is, it's not a very intuitive environment. It's pretty much just set up for some quick and dirty tests. Like if you need to test something out, great, this is a perfect place for it, because you don't have to set up a file, you don't have to use like some IDE, you don't have to execute a file. You just go in here, it's quick, it's dirty, you get it done. But if you're writing like an actual program, you definitely want to use a text editor. The text editor is just gonna be way more organized, everything's gonna be a lot clearer, and you're not gonna get confused with like where stuff is and what you have. So that's the basics of the Python interpreter. You know, in the course, I haven't really been using it at all, just because I think it's a lot easier to teach when we're inside of a file than inside of here. But, you know, don't count this guy out. The Python interpreter is awesome. A lot of people use it, and it's great if you just need to test, you know, little bits of code out without having to set up some huge environment. So Python interpreter, definitely awesome. I would play around with it, you know, have some fun, and take advantage of it. Hey, thanks for watching. If you enjoyed the video, please leave a like and subscribe to Draft Academy to be the first to know when we release new content. Also, we're always looking to improve, so if you have any constructive criticism or questions or anything, leave a comment below. Finally, if you're enjoying Draft Academy and you want to help us grow, head over to draftacademy.com/contribute and invest in our future.
Hey guys, how's it going? So I've been coding for 5 years.
this fight. I've seen it before. It gets as bad as it can get.
I don't care. I'm not training if you don't get the treatment. So if I fight, you fight.
I am within transition.
You're within transition.
Yes.
talking Lord knows that I repent for this. But Lord knows if I get pinned for this, I probably won't get home until I'm 56. They say, I don't know why they be guessing these suckers before, cause I am not feeling that shit. Different between me and most of these rappers, I'm talking about work that I really put in. Talking about pistols I put on my hip, and I'm talking about foreigns I really do it. So talking Lord knows that I repent for this. But Lord knows if I get pinned for this, I probably won't get home gift and my bitch so bad she on my Christmas list. Remember I prayed really, I wish for this. To get the crib with the maid and with the picket fence. I'm with some niggas that mad, we took a risk for this. So talking Lord knows that I repent for this. But Lord knows if I get pinned for this, I probably won't get home until I'm 56. They say, I don't know why they be guessing these suckers, but fuck 'em, 'cause I am not feeling that shit. Different between me and most of these rappers, I'm talking about work that I really put in. Talking about pistols I put on my hip, and I'm talking about foreigns I really do it. gift and my bitch so bad she on my Christmas list. Remember I prayed really, I wish for this. To get the crib with the maid and with the picket fence. I'm with some niggas that mad, we took a risk for this. So talking Lord knows that I repent for this. But Lord knows if I get pinned for this, I probably won't get home until I'm 56. They say, I don't know why they be guessing these suckers, but fuck, cause I am not feeling that shit. Different between me and most of these rappers, I'm talking about work that I really put in. Talking about pistols I put on my hip, and I'm talking about foreigns I really could win. Christmas gift and my bitch so bad she on my Christmas list. Remember I prayed really, I wish for this. To get the crib with
Hello friends, today I am going to show you how to invert a dictionary in Python. I'll show you two methods to do this. Method 1 is using dictionary comprehension and method 2 using zip function. I have declared a dictionary called D with keys A, B, C and value 1 to 3 as you can see here. The first method is using dictionary comprehension, which is fairly easy. You say V colon K for K comma V in D dot items, which will basically return the key value pair, and in B colon K I have interchanged them. So if you see this, say it will return the values and keys have exchanged as you can see here. So this is the first method, which is fairly simple, and the another method is using zip function, which you can do something like zip then D dot values comma D dot keys. So if you say this, it will return a zip object of all the tuples from the dictionary. So you have to run a dictionary function on this object, which will basically return you the desired output. So you can see here also the keys and values have exchanged themselves.
That we have to create a dictionary. To again show you few more programs in dictionary. So the first program which I am going to show you, that is that we have to create a dictionary and then we have to show the dictionary in an inverted form. Inverted means where the key will become the value and the value will become the key. How we can do it? It is very easy, as we have done yesterday also, that we have used the sorted function to sort it the key and value with the value and key. So what we will do, we will read the first of all we will write the looping function for reading the key and value. So you can see that I have used a variable x for storing the dictionary, and then I am writing here key 1 value 1, key 2 value 2, key 3 and value 3. But what I need the as output, I want the output as in the inverted form, wherein I will get v1 key k1, v2 k2 and v3 and k3. So k stands for key and v stands for value. So for that I have to read the key and value first of all. So I am writing here the for loop for the which I will read the key and value one by one, as we have done yesterday also. So I am writing here for key comma value in D, not D, actually the name of my dictionary is X. So I am writing here x dot items. So I've written for key comma value in x dot items. So now what we have to do, we have to sort it. So for sorting, not exactly sorting is there, we have to just do it opposite. We have to invert it. Now key will become value and value will become key. So I'll take a variable here x1, wherein I'm going to store this, where key will become value. So I'm writing here curly braces, value is to key. Alright, and then I will close it and then print x1. So how this is gonna work, you can see here that first of all dictionary x is created, wherein key comma value is given, and now here in the x1 I am storing the value comma key. Once the key comma value is read in x dot items, now x dot item is going to return the item in the form of key and value. So now key and value is read and then it is inverted. So key has become value and value has become now key. So this is how we have written, and whatever is stored in x1 we have printed it. Let us see that how it got printed. Is it coming according to our requirement or not? You can see here now v1 value comes here first and then corresponding key has become the value and value has become the key. If it is not understood like this, let us do some changes with the output. Let us print the original dictionary here. First of all I have written print x. Now after inverting it, let me write one sentence here, print inverted x, and then I have printed this x1. Now let us execute, so we will be able to see the output of both the form. So now you can see the original dictionary was like this, k3 v3 k2 v2 k1 and v1. As it is, the dictionary is an unordered collection of data, so you can see it is an unordered form. Now inverted x, after inverting it, how it has become, now key has become value and value has become key. So v1 k1, v2 k2 and v3 k3. This is how we were expecting, and this question is solved. I hope you have understood it. If now the last question which I am going to solve is that we have to create a two dictionary here, and then we have to display the duplicate keys among it. So if there will be any kind of duplicate keys in both the dictionary, we have to show you. So let us begin with this. So for this we have to define two dictionary first of all. So I'm writing here dictionary 1 equals to, now let us see here, let's write A is to apple, B is to ball, then C is to cat. All right, and let us write the again second dictionary D2, wherein I am going to repeat one of the key of here, not all. All right, and let's B should be repeated here, and then let me write here E. All right, so you can see here that I have created two dictionary wherein I is present, and in D2 also the B key with the value ball is present. Now as we know that there should be a duplicate key in one dictionary, but it can be in two dictionaries. However, we have to find out the duplicate keys in both the dictionaries. So what we are going to read, the concept will be that I'll read one dictionary at a time, and then I'll match it with the key of the dictionary 1. So I'll run a loop here. So I'm writing here loop for key comma value in. Now I'm reading the dictionary 2 here. So what will be the concept, that we will read the dictionary second and then we will match with it with the key of the dictionary 1. So for reading the dictionary second, I have written for key comma value in dictionary 2 dot items. So all the items is here, and now the dictionary key and value are read together. Now what we have to do, we have to match the key of the dictionary 1 if key in dictionary 1 dot keys. So with the help of key function we can get the key of the dictionary 1. So I have written here d1 dot keys, which is going to return the key only to me. Now we have to find out the duplicate keys only, not the values, so I have written d1 dot keys. Now d1 dot keys will give me the key of the dictionary 1, and here I have used k variable for the reading the key of the dictionary 2. So I am matching it, that if k is in dictionary 1 dot keys, it is matching, then print that key. It means it is a duplicate one. Alright, so let us execute this and see that what the output comes. So I am getting it executed. Now you can see that we got the key, which is B, which is the duplicate one. If you add one more duplicate, it will give you both the answer. Let's see. So two keys are duplicate now here. Let us see the output. So you can see that C and B both are the duplicate keys here. So this is how you can solve this question, that you have to define two dictionaries here. Now for you can read the item of any one dictionary by d2.items. You can read both the key and value of that dictionary, and then the key of this
Hey there, how's it going everybody? In this video, we'll be learning about dictionaries and how we can work with them in Python. So dictionaries allow us to work with key value pairs. And if you're coming from another programming language, then you may have heard these called hash maps or associative arrays. So when I say that we'll be working with key value pairs, these are two linked values where the key is a unique identifier where we can find our data, and the value is that data. So we can actually think of that almost like a real physical dictionary where we look up word definitions. So in that example, each word that we look up would be the key, and the definition of that word would be the value. So let's go ahead and take a look at some examples. So let's say that we wanted to represent a student using a dictionary. So to do this, we could just create a student variable and set this equal to these curly braces, and that's how we start our dictionary. Now within our curly braces here, we will first put in our key. So let's say that we want a key of name. Now we're going to put in a colon to separate our key from our value. And for the name here, we'll just start off with John. And now let's add some more keys and values, and to separate these keys and values, we're going to put in a comma. So next, let's put in a key of age and a value of 25. And lastly, we'll put in a key of courses, and for this value, we'll pass in a list of courses here. So we'll say math and comp sci. So now let's print out our student and see how that looks. So if we save that and run it, then we can see that it prints out all of our keys and values. Now let's just get a value of one key. So to do this, we can add square brackets after our dictionary and then specify the key that we want to access. So I can put in square brackets here, and let's say that we want to access the name of that student dictionary. So I'll just pass in the name key and run that. And we can see that that gave us that value of that name key. Now, if I wanted the courses instead, then I could just pass in that courses for the key. If I run that, then you can see that we got this list of math and comp sci. So we can see that these values in our dictionary can be just about anything. Our name is a string, our age is an integer, and the courses are a list. Now, all of our keys are currently strings, but they can actually be any immutable data type. So usually these will either be strings or integers, but there are a few more data types that they can be as well. So for example, instead of name as our key here, if for some reason we wanted this to be an integer, so I'll just pass in 1. So a 1 is a valid key. And now if I access that key of 1 and run that, then you can see that that gave us John. But I'm going to set that back to be a string for now and keep that as name. So what happens if we try to access a key that doesn't exist? So for example, I'll try to access the key of phone for a phone number. So if we run this, then we can see that we get a key error because that phone key doesn't exist. Now, throwing an error when a key doesn't exist might not always be what we want. So sometimes we might just want to return none or a default value. So to do this, we can use the dictionary's get method. So instead of accessing this key this way, if we were instead to say .get and use the get method, so let's just go ahead and get the name since we know that that key already exists. So if I run that, then we can see that that works just like before and gave us the value of John. But if I try to access a key that doesn't exist, so we'll try to access that phone key again, if I save that and run it, then by default, this get method returns none instead of an error. And we can also specify a default value for keys that don't exist. So to do this, we can just pass the default value that we want as a second argument to this get method. So I'll just put in a comma here and we'll put in a string that just says not found. So if I save that and run it, now we can see that for keys that don't exist, it returns not found. Okay, so let's look at how we can add a new entry to our dictionary. So let's say that we wanted to add that phone number to our student dictionary, and we'll set this just above our print statement here. So to do this, it's just as easy as saying student, and then we will set the key that we want to set and set this equal to, and we'll just set this equal to a string of 555, 5555. And if I save that and run it, then we can see that it found that value of the phone key when we ran our print statement. Now, if a key already exists, if we set its value like this, then it will update the value of that key. So for example, if right below this, I was to say student and name is equal to, and we'll just pass in Jane. If I save that and then print out, I'll comment out that for now. If I print out our entire student variable, then we can see down here that the value for name was updated when we assigned it to Jane. Now we can also update values using the update method. Now this is especially useful when we want to update multiple values at a time. So for example, let's say that we wanted to add this phone number, update this name, and also update the age as well. So to do this all in one shot, we could say student.update, and this takes in a dictionary as an argument. And the dictionary is just everything that we either want to add or update. So we can say that we want to update that name to Jane, and we will update the age to, let's say, 26. And we also want to add this phone key, and that phone key will just set as what we had before, 555, 5555. Now, if I save that and run it, then we can see that just by running this one statement, we updated the name to Jane. The age is now 26, and it has this new key of phone number. Okay, so now let's say that we wanted to delete a specific key and its value. Now, one way that we can do this is by using the del keyword, which stands for delete. So let me just remove these updates here, and then we can say, so let's say that we wanted to delete the student's age. So it's as easy as just saying del student age. And now if we run this, then we can see that now the only keys that exist are name and courses. So that age key was deleted. Now, another way that we can remove a key and value is with the pop method. So if you remember from our video on lists, the pop method will remove but also return that value. So that allows us to grab the removed value with a variable. So we could say age is equal to and do a student.pop. And what we want to pop is that age. So if I save that, then we'll also print the age here below student. If I run that, then we can see that the age and value were removed from our dictionary. But if I run that, pop. The way that we can remove a key and value is with the pop method. So if you remember from our video on lists, the pop method will remove but also return that value. So that allows us to grab the removed value with a variable. So we could say age is equal to, and do a student.pop. And what we want to pop is that age. So if I save that, then we'll also print the age here below student. If I run that, then we can see that the age and value were removed from our dictionary, but we also created that age variable that contained the value that we popped off. So that popped off 25. Okay, now let's look at how we can loop through all the keys and values of our dictionary. So let's look at how we can loop through all the keys and values of our dictionary. So first, if we want to see how many keys we have in our dictionary, then we can just print out its length with the len function. So if I was to say print len of student and run that, then we can see that it returns 3 because we have 3 keys in our student dictionary. Now, if we wanted to see all of these keys, then we could just print out student.keys. If I run that, then we can see that that gave us all of the keys of our dictionary. If we wanted all of our values, then we could print out student.values. If I run that, you can see that that gives us only the values. Now, if we wanted to see the keys and values, then we could use this items method. If I run this, then we can see that now we have these pairs of key and value pairs. So we have name John, age 25, courses with the list. And we'll be coming back to these pairs in just 1 second. So if we wanted to loop through all of the keys and values in our dictionary, we might be tempted to loop through the same way we loop through our list. But if we just loop through our list without using any method, then it'll just loop through the keys. So for example, if you were to say for key in student and then print out that key, if we run this, then we can see that it just looped through and printed out all of those keys. Now, in order to loop through the keys and values, we'll need to use that items method that we just saw a second ago. And so we'll just plug that in there. We'll say student.items. And now these come in a pair of 2 values. So instead of just key, we're also going to have to access the value. So we can say for key value in student.items. And now we'll print out the key and that value. So if I run that, so we can see that each loop through, this key variable was equal to each key, and this value variable was equal to each value. Okay, so I think that's going to do it for this video. I hope that now everyone feels comfortable working with dictionaries and the functionality that's available to us. And in the next video, we'll be going over conditionals and how to write if, else, and elif statements. We'll also be learning more about booleans and boolean operators. Now, if anyone has any questions about what we covered in this video, then feel free to ask in the comment section below and I'll do my best to answer those. And if you enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up. And also, it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos, and thank you all for watching. Hey there, how's it going, everybody? In this video, we'll be learning about Hey there, how's it going, everybody? In this video, we'll be learning name is a string, our age or current an integer, so I'll just pass 1 and run that. Then you can see that that gave us John.